Are you ready to take your SQL skills to the next level? Whether you are a seasoned data professional or just diving into the world of databases, you are in for an exciting journey. I'm thrilled to welcome you all to the new YouTube series where we will embark on a mission to conquer advanced SQL through a collection of 50 Leetcode questions straight from the trenches of real data science interview at some of the biggest companies out there. In this series, we will dissect each question, unraveling the complexities and unveiling the secrets behind optimal SQL solutions. From tricky joins to complex subqueries, from window functions to common table expressions and recursiveness, we will leave no stone unturned. And here's the best part, every question we tackle is handpicked from the actual data science interviews from top tier companies like Google, Microsoft, Amazon, Meta, etc. That's right, you will be learning the same skills that can land you a dream job in tech industry. So whether you are aiming for that coveted data scientist position or simply looking to supercharge your SQL prowess, this series is tailor-made for you. And do not forget to hit the subscribe button and ring the notification bell so that you never miss any new video. Trust me, you won't want to miss out on this SQL adventure. If you are new to this channel, I have already covered basic and intermediate level SQL in SQL 50 playlist where we covered diverse aspects of SQL using 50 carefully curated questions. So yeah, if you are new and if you want to learn the SQL from basics, you should start with this playlist and then come back to the playlist that we are going to start today. So this is the first video of the series, find customers with positive revenue this year. And if I look at the companies this question has been asked in, so Google interviews, kind of an important question. Let's look at what the question has to say. We are given a table called customers with three different columns, customer ID, year and revenue, with all the data types being integer. The combined columns customer ID and year is the primary key, that is combination of columns with unique values for this table. This table contains the customer ID and the revenue of customers in different years. Note that this revenue can be negative. We are asked to write a solution to report the customers with positive revenue in the year 2021. Order of the result does not matter. So let's go through this example and see what do we need in our output. So here we have various customers, the years and the revenue. So in 2021, what all customers had a positive revenue, that is revenue greater than 0. So for 2021 we have 1, 2 and 3 rows for customer ID 1, 2 and 4. But for customer ID 2 in year 2021 the revenue was negative 50. So the only two customers who have positive revenue in year 2021 is customer ID 1 whose revenue was 30 and customer ID 4 whose revenue was 20. So 1 and 4 should be in our output. So basically this is very simple. What we need to do is we need to perform filtering using the where clause. So from this table called customers, we need firstly to look for those rows where year is equal to 2021 and also the revenue should be positive. So and clause and revenue is greater than 0 and then we need to return the customer ID. So return customer ID. Okay, then you might ask why we are not doing distinct customer ID. Here we have repetitions, right? So you see in this table, it has been written that the combined column customer ID and year is the primary key. That is, it is going to be unique values. So since we are already specifying a particular year, so all the customer IDs related to it is going to be distinct. So you do not need to write the redundant distinct here. Okay, let me go ahead and run this. Let's see what do we get in our output. So this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. Not a very difficult question. All we had to do was what we learned in our SQL 50, that if you want to perform a filtering based on two different conditions, you can use the where clause along with the and clause to specify all the conditions that you want to check for, and then we return the customer ID. So this is the second video of this series called customers who never order. And if I look at the companies this question has been asked in, so Amazon, Apple, Bloomberg, Adobe, a number of times. Very important questions. Let's look at what the question has to say. We are given a table called customers with two different columns, ID and name, ID being the primary key, that is column with unique values for this table. Each row of this table indicates the ID and the name of a customer. We are also given a second table called orders with again two different columns, ID and customer ID. ID is the primary key for this table. Customer ID is a foreign key, that is a reference column of the ID from the customers table. Each row of this table indicates the ID of an order and the ID of the customer who ordered it. Okay. we are asked to write a solution to find all customers who never order anything. Order of the result does not matter. So here let's look at an example and see what do we need in our output. So for example, here we have 4 different customers and various orders. So there are 2 different orders, order ID 1 and 2, ordered by customer ID 3 and N. Customer ID 3 is Sam, so Sam has ordered something. Customer ID 1 has ordered something, so 1 is Joe. So Joe and Sam have ordered something. So the customers who have never ordered anything are Henry and Max, and that is what we have in our output. To solve this, we have learned in our previous SQL 50 series that these type of questions where you need to reach outside of a table to actually get something is achieved using a outer join. Left join, right joins, etc. are examples of outer join. That is, you reach out to another table to get information. So for each of the customers, we can perform a left join to get, okay, for every customer, what all orders they have made, because once we know that for all the customers who have made orders, then it is very easy to identify who all have not ordered anything. So what I'm saying is, from this table called customers, let me alias this as C, left join the orders table aliased as O on C dot ID is equal to O dot customer ID. Remember, the question says customer ID column of the orders table is a foreign key of the ID column of the customers table. Okay, let me go ahead and return everything. So let's see what do we have in our output. Okay, so let me go ahead and run this. Okay, so if I look at our output, so here we have for all the customers here that we have in our customers table, what are the orders that are associated with it. So Joe ordered something, Sam ordered something. So obviously when you are not ordering anything, there is going to be nothing in the orders table. So for those customers, there will be nulls in the columns coming from the orders table because there was no match. So obviously we are interested in only those types of customers who are not ordering anything. So we need to make sure that we are only considering those rows where any of these 2 columns, either the ID or the customer ID, it makes more sense to include the ID because this ID represents the order ID. So O.ID is null. Basically this signifies all those rows where there was no order placed, right? So for these type of rows, we need to return the names of the customer, and this should be aliased as customers. So name column comes from the customers table. So we write C dot name, and this should be aliased as customers. Okay, since we do not need to order this, let me go ahead and run this to see what happens. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how to do it. Not a very difficult question. All we had to do was perform and apply our logic of left outer join. So we perform that, and since we are only interested in those customers who have not ordered anything, so order ID related to them would be nulls, and because of that we are going to return the names of such customers. So this is the third video of this series called calculate special bonus, and the companies, if I look at, so this question has been asked in Apple interviews a couple of times. Let's look at what the question has to say. We are given a table called employees with 3 different columns: employee ID, name and salary. Employee ID is the primary key, that is column with unique values for this table. Each row of this table indicates the employee ID, employee name and salary. We are asked to write a solution to calculate the bonus of each employee. The bonus of an employee is 100% of the salary if the ID of the employee is an odd number and the new employee's name does not start with the character M. The bonus of an employee is 0 otherwise. Return the result table ordered by employee ID. Okay, let's look at this example. So here we have certain employee IDs and their names and their salary. So for every employee ID, the bonus is 100% of salary if the employee ID is odd and their name does not start with M. So for example, if we look at employee ID 2, so obviously this is not an odd number, so bonus for 2, 8 is going to be 0. Now for 3, 7 and 9, since they are odd, we need to check the other condition, that whether their name starts with M. So yes, for employee ID 3 it does. So here also we have bonus equal to 0. For 7 the bonus is going to be 7400, and for employee ID 9, since it does not start with M, so bonus is going to be 7700, and that is what we have in our output. So basically what we need to do is we need to have this employee ID as well as create a new column based on certain conditions and alias this as bonus. So what we need to do is, from this table called employees, we need in the output the employee ID. So return employee ID and then use the employee ID and the name column to basically come up with the bonus column. Okay, so you can either do this using case when statements, because you have to check for multiple conditions to assign the value in the bonus column, or you can use the if function as well. Since here we only need to check one compound condition, that is two conditions based on one, right? So here your bonus is 100% if it is an odd number and employee name does not start with the character M. So you can also use the if function if you want. So let me go ahead and use the if function. So if the first condition is that the employee ID should be odd number. So if you divide the employee ID by 2, the remainder should be 1. That means that it is an odd number. And then you also need to make sure that and now also, since here text are involved, right? So name, text are involved. In some of the rows, it is possible that it starts with lowercase m. So just to have the uniformity, what you can do is you can either convert the entire characters into uppercase or lowercase. The convention is usually to convert into lowercase. So what I'm doing is, before comparing whether the name starts with the letter M or not, what I'm doing is I'm converting the name to lowercase. So lower this entire thing, lower name, and then it should be not like, so it should not be like M ampersand. So what does this mean is, so it should not start with M. So anything after M does not matter, but it should not start with M. So not like this. So if both of these conditions, so here this should be also in the bracket so that we know that okay, this is another condition. So and this is not like this, then if both of the conditions are true, then you return 100% of salary, or basically the salary. If any of this is false, you return 0, right? And then this should be aliased as bonus, because that is what we need in our output. And then we should also order this by employee ID in ascending order. So we can go ahead and write order by employee ID. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Not a very difficult question. All we had to do was combine the knowledge that we have from SQL 50, where we used to check, string functions, how to check for string functions, how to check for odd values, how to use if function. Here also, if you want to do this using case when statements, you can do this using case when statements as well. Such as, if you just simply go ahead and remove all this, right? So if you just write case when this is equal to true, and the second condition, let me just bring it down here. The second condition is lower the name is not like this, then, right? So here in this case of commas, you need to write then you return salary, else you return 0. And whenever you start a case when statements, you need to end this. So end, and then this, remove this bracket or parentheses, and it'll end as bonus. If I go ahead and run this, this is basically doing the same thing, right? So accepted. If I go ahead and submit it, this is going to pass all the test cases. So this is accepted as well. So this is the fourth video of the series called customers who bought products A and B but not C. And if I look at the companies this question has been asked in, so Amazon and Facebook, kind of an important question. Let's look at what the question has to say. We are given a table called customers with two different columns, customer ID and name. Customer ID is the column with unique values for this table, and customer name is the name of the customer. We are also given a second table called orders with three different columns, order ID, customer ID, and product name. Order ID is the column with unique values for this table. Customer ID is the ID of the customer who bought the product name. We are asked to write a solution to report the customer ID and customer name of customers who bought products A and B but did not buy the product C, since we want to recommend them to purchase this product. Return the result table ordered by customer ID. Okay, let's go through this example and see what do we need in our output. So here the customer ID 1 has bought products A, B, C and D. So since the person has bought A, B but also bought C, so this should not be in our output. Customer ID 2 has only bought A, so this customer also does not qualify for our conditions. Then we have customer ID 3 who has bought A, B and D. So obviously this person has bought A, B but not C. So this should be in our output. And for customer ID 4, the person has only bought C. So in our output, we need to have customer ID 3 and the name of the person is Elizabeth, and that is what we have in our output. Okay, so just by looking at it, I can think of two methods that we can take to solve this question. Let me switch to Excel to demonstrate this. So first method can be, we can group by the customer ID and find that, okay, how many times they have bought A, B and C. So here ones and zeros does not mean yes or no. Here it means how many times they have bought it. So 0 means bought 0 times and 1 means bought once. Okay, so once we, and this is how the solution will look like, that from this orders, if you group by customer ID, right, and you return the customer ID, and here you can see that here you have to write a number of case when statements to get this type of table, and from this you can simply say that, okay, wherever your bot A is not equal to 0, bot B is not equal to 0, but bot C is equal to 0. What does this signify? That the person has bought A and B but has not bought C. Return those customer ID. So obviously from this you can get this row as your output. But you can think of it, right, if here you have only two conditions, that bought A and B and not C. But what if the question is generalized and the person asks like, okay, bought A, B, C, D, E, F, G, H, I, but not X, Y, Z or something like that, you know, some weird condition. So in that case, you would have to write a lot of case when statements. So what is the better way to do this? Here, to make your solution even more generalized, you can adopt method 2, and that is what we are going to discuss in our video. So what you can simply do is, for every customer, you can simply find out what are the different products that were bought by this customer ID and get that in a particular row. And how can you do that? Remember, in our SQL 50, in the later stages, we learned about a function called group concat. We can employ that here. So let's see how we can do this. Also, before, you know, going there, since we also need the customer name, so it is okay to, you know, perform a join of orders table as well as customer table before that. If you want, you can do it at the later stage also, but what I like to do is, you know, have that at one place so that, you know, we can start building our logic. So from this table called orders aliased as O, let me left join the customer table. So let me just scroll it up. Yeah. So customers table alias as C on O dot customer ID is equal to C dot customer ID, and all I require from customers table is the name, because I need that in our output. So O dot asterisk, so this means keep all the columns from the orders table and only keep the customer name from the customers table. So C dot customer name. Let me go ahead and run this. Let's see, we are having what we require, right? Okay, so if I look at our output, so now we have order ID, customer ID, product name and customer name. Okay, so now once we have this, then we can start building our logic based on method 2 that we discussed here. That is, we can group by the customer ID and group concatenate the product name. So what I'm saying is, let's go ahead and from this, right? So this is what we have right now, group by the customer ID. So group by the customer ID is coming from the orders table. So O dot customer ID, and then you return O dot customer ID, and then group concat, and then we want distinct products, right? We want distinct products arranged in increasing manner so that, you know, it's easier for us to filter. So distinct product name, and this should be order by product name in increasing manner, right? So by default it arranges in increasing manner, and let me alias this as products bought. Okay, so let me go ahead and run this. Let's see what do we get in our output. So now here, if we look at it, so this is exactly the same thing that we were trying to get, right? So 1, 2, 3, 4, and what are the different products this person has bought. So once you have this, then it is quite simple from here, right? So here you can say that, okay, once you have this, you keep only those rows where your products bought has A and B in them, but does not have C in them, right? So that means the person has bought A and B, but not C. How can you do this? So having, right, having this products bought, right? So products bought, like, so it should be A and B, and since we have already arranged in increasing manner, so it will start with A and B. So A and B should be next to each other. So A and B is like A comma B, and then after this it can be anything, right? Let me go ahead and run this. Let's go step by step here. Okay, so if I look at it, so A and B have been bought by two customers, 1 and 3. Then we also need to make sure that products bought is not like, so there is no C in them. That is when you are going to recommend that person. If the person has already bought C, then what is the use of recommending him, right? So, and products bought is not like, and then percentage C. So anything before this or after, but C should not be there. If I go ahead and run this, let's see what do we get in our output. Okay, so now in our output, we have the perfect customer ID that we want in our output, right? And these are the products the person has bought. But we do not need the products bought. We need the customer ID and the name of the customer. Okay, another question that might arise, like why are we using having clause here? Didn't we learn in SQL 50 that having is used when we are filtering based on an aggregate? And here it seems like it is better to use where clause. No, you remember here you are doing a group concatenation. Having is used when you are filtering based on an aggregate value, and here you have aggregated, right? So all the products that were bought, you are aggregating using group concat, right? So that is why having works here, right? Remember that. See how the concept that we built in SQL 50 are being utilized here one after the other. So if you have not watched that SQL 50, I've highly recommend you to do so before jumping on the advanced SQL 50. So yeah, once we have this, then since in our output we need the customer ID and the customer name, so obviously instead of having products bought, you can simply replace this products bought with this entire thing, because in our output you only need that, right? So what we can do is, instead of this, let me just cut this entire thing, right? What kind I can basically do is, here I can just simply paste it here, right? And again simply do it here as well, right? So that this will free up this part, and here I can simply go ahead and return the name of the customer, right? So name of the customer is going to be C dot customer name. Oh, also remember, we learned about this in group by. We are not grouping by this customer name, right? So here you need to add that in your group by as well, right? So if this is more confusing to you, then I would suggest do not do this join here. Have everything ready for orders, and at the end join this customers table on customer ID columns from both of this. That would be easier to understand, right? Okay, let me go ahead, and here we need the customer ID column as well. Okay, let me go ahead and run this. Let's see what do we get. Okay, so if I drag it above, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. Yes, kind of a tricky question, and here you have to use your brain to think about various concepts. Firstly you need to perform a join, then you group by, and then you also have to make sure that that for every customer ID and customer name, what are the different products that were bought. So we used group concatenate and return distinct product names sorted in ascending order, and then we made sure that the person has bought A and B but not C. And why we are using having in this case? Because we are actually filtering based on a aggregate value. So this is the fifth video of this series called highest grade for each student. And if I look at the companies this question has been asked in, so Amazon and Coursera, kind of an important question. Let's look at what the question has to say. We are given a table called enrollments with 3 different columns: student ID, course ID, and grade, all of them having data type integer. The combined column is student ID and course ID is the primary key, that is combination of columns with unique values for this table. Grade is never null. Okay, we are asked to write a solution to find the highest grade with its corresponding course for each student. In case of a tie, you should find the course with the smallest course ID, and the results should be ordered by student ID in ascending order. Okay, so let's go through the example and see what do we need in our output. So for every student, we want the course with the highest grade and with the course ID, and in case there is a tie, so the course with the lowest course ID should be in our output. So for student ID 1, what is the highest grade? 99, right? And since there is no tie, so for student ID 1, the course ID 2 and 99 should be in our output. For student ID 2, in both of these courses, the person scored 95. So obviously the smallest course ID is 2. So for student ID 2, course ID 2, grade 95 should be in our output. And for student ID 3, the highest is 82. So 3, 3 and 82. And that is what we have in our output. Okay. Let me switch to Excel so that we can develop our query. So there are two major methods of solving this question. First one is a beginner or intermediate level solution where we are going to use joins and filtering to solve this solution. But there is another method, advanced method, where we are going to use a window function and see how a window functions actually works step by step. And I'm also going to talk about how the different ranking functions, row number, rank and dense rank, actually rank things by taking an example. Okay, so let's go to the first beginner or intermediate level overview, because we are going to develop and mainly work on the window function here. But just think about it. Here you have the table enrollments, right? So what you can do is, firstly, you can group by the student ID and find the maximum grade, right? So for example, for student ID 1, the maximum would be 99, for 2, 95, and 3, 82. So that is what we have here. Name this table as T, and we can join this on student ID of enrollments and student ID of the table that we created. So that is what we are going to get, right? So all these three columns coming from the enrollments table, and the maximum grade is added. Now after this, we are only interested in the maximum grade for each student, right? So what we can do is, the next step could be, that is step number 2 could be grade is equal to maximum grade. So these are the 4 rows that we are going to be left with. Now here again we need to find out that, okay, for every student, if the grade is equal for two different course IDs, for example for student ID 2, we need the minimum of the course ID. So again, where here we can go ahead and do a group by student ID and find the minimum of course ID, and you can do maximum or minimum of grade because it won't matter, because you already have mentioned that your grade is equal to the maximum grade. So that is how you can finally achieve this answer if you are a beginner or intermediate level solver, right? And this is how the solution will look like. So firstly, you created this table grouped by student ID, get the maximum grade as maximum grade. We performed a left join on enrollments using e.student ID is equal to t.student ID. Then we, which basically gave us this table, right? This table. And then once we did where e.grade is equal to t.max grade, these are the 4 rows that we are left with. And then finally what we did was, we grouped by the student ID, and they return the minimum of course ID, because that is what it says in the question, that if there is a tie, you return the minimum. And then either you can do minimum or maximum, because it won't matter in this case. And then ordered by student ID, and finally we achieved our solution. Okay, but in this video, let's talk about the method 2 or a window function and how this entire thing, right? So here, if you see, this is a 4-step solution. First step is this, that you grouped by student ID and get the maximum grade. Then you performed a left join, so step 2. Then you performed this, so step 3. And finally, you received the answer. While using method 2, that is a window function, we can combine step 1 and 2 into one, and this will make our tasks way easier. So what we are doing is, just as a name suggests, window is basically used to define in a particular data a certain window. So you are not taking in the entire data set enrollments, you are creating certain windows, and the way to do it is using a clause called partition, right? So basically, if I go ahead and here, let me start writing the solution so it will make more sense. So if I write from this table called enrollments, right, from this table called enrollments, I need to keep all the columns for now, select star, and then the syntax of a window function is, we always write the over clause. So window function always starts with the over clause. So we write over, and then what we need is, if you think it at a basic level, when we grouped by the student ID in the beginner and intermediate level solution, we grouped by the student ID and found the maximum grade. So what we basically did was, we made groups based on student ID. So if we do the same thing, basically create partition. So for every student, we create that, okay, for student ID 1, these are the only 2 rows that I need to consider. For student ID 2, these are the only 2 rows which I need to consider. For student ID 3, these are the only 3 rows that I need to consider. So over partition by student ID. So for every student, create a partition. So if I go here, so this is what it will do. Partition by student ID. So okay, these two rows becomes one partition. These two rows becomes another partition. These three rows becomes another partition. You see, this is how right now we are at. So partition, and then we also need to order by, because we need the highest grade in the first, right? So what we do is partition by student ID and then order by grade in decreasing manner. So order by grade in decreasing manner. So here 99 comes before 90, right? Let's leave this for now. And then here 82 comes before 80, and then 80 comes before 75. Okay. Now this question says that in case there is a tie of the grade, then you should find the course with the smallest course ID. So basically what you need is order by grade in descending manner. And if there is a tie, then what you do is comma, then course ID in ascending order, right? So this is going to give you for these kind of cases that okay, you have a partition for student ID 2, 95 and 95, but whether this row should come first is based on, okay, since we are ordering by course ID in ascending order, so now we have these two rows. Okay, once we have this, so partitioned and ordered, then what we need to do is we need to rank. Now, let's divert a little bit and learn about how to rank in SQL using window functions. So, there are three different ways of ranking. It's called row number, rank, and dense rank. And there is a difference between these three and various use cases where they are used. So, for example, here is an example that I have taken and sorted in ascending order. So, you have 1, 2, 2, 3, 4, 5, 5, 5, 5, and 6. So, first one is row number. Think of row number as like it does not matter to it, that whatever is your sequence, it will just keep on adding ones to it. So you know, so this becomes row number 1, 2, 3, 4, 5. So it's just literally a row number string. So what happens in rank is that if you, so you start, so the least one is 1, right? So it will rank it at 1. Then you have 2, so this will be ranked 2. All the ties are ranked same, but if you are using rank, this will skip one thing, right? So here ideally, right, so for row number it should be 3, right? But for rank, since these two are the same things, obviously this is ranked the same value 2, but it will skip 1, right? So here it will be ranked 4, then 5, then this one is 6, right? Now all these three are going to be ranked 6, 6, 6. So how many times there are ties? 3, right? So it will skip how many ranks? 3 minus 1, 2. So after 6, it will skip 7 and 8, and it will go to 9. So you see, one thing to note about row number and rank is, however you rank it, the last value of both row number and rank will be the same thing, right? Keep that in mind. And dense rank, what it is very similar to rank, but here in case of ties, it won't skip ranks. So here this will rank this as 1, these two as 2, but instead of ranking this as 4, just like in rank, it will rank this as 3, then 4, then 5, 5, 5, and no skipping, so 6. So that is how it is ranked here. Now, in this case, just by looking at it, which one, there is only one function that we can use, and that is row number. Why? Because if you use rank and dense rank, right? So let me go ahead to method 2. Here, if you use, let's say, rank or dense rank, so here this will be ranked 1 and 2, no problem, because there is no tie. This will be ranked 1, 2, 3, no problem, but these will be ranked 1 and 1, right? But in our output, we need, whenever there is a tie, we need the row with the minimum course ID, right? So that is, we need to make a distinction between course ID. But had the case been that it would have asked, okay, if there is a tie, return all the courses where the marks was same or the equal to highest, then using rank or dense rank would make more sense. So the only ranking function that can be used in our case is row number. So we can go ahead and write, okay, after you partition by student ID, order by grade in decreasing, and in case of a tie, course ID by increasing, you use the row number function to rank, and let's alias this as RNK. And let me go ahead and run this. Okay, let me just bring it down here and format this. Okay, let me go ahead and run this. Let's see what do we get in our output. Let me drag it above. So here, if we look at our output, so here, what these are the ranks that we just saw, right? So 95, this one is ranked 1, 2, 1, 2, 3, 1, 2. So now once we have this, then we basically now have rank ones are associated with those rows where the grade is highest, and if there is a tie, the course ID is the lowest. So both our conditions are being satisfied by the rows that are rank is equal to 1, right? So here this is what we did, and simply we can go ahead and write where rank is equal to 1. This is going to leave us with the 3 rows where rank is equal to 1, and we can attain our final answer. So let me just go ahead and do this. So this entire thing becomes one of the tables, right? So this becomes one of the table. Let's, alias this as whatever tab or whatever, does not matter. And then keep only those rows where tab dot rank is equal to tab.rnk is equal to 1, right? And for them we need to keep only the 3 columns. So we need the student id, so tab.student id, tab.course id, and tab.grade, and this should be also arranged in ascending order by student id. So order by tab.student id in ascending order. Let me drag it down. So this is how the entire solution will look like. Let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Yes, you can either use joins and filtering based method, or you can use this advanced method of using window function. And I just, talked about how a window function actually works, how those windows and partitions and orders are created. And then what we did was we simply ranked based on the conditions that were given, that, of highest grade, and in case of a tie, course with the smallest course ID. So wherever your rank was equal to 1, that satisfied both the condition, because that is how we used our window function. And then we ordered by student ID in ascending order. So this is the sixth video of the series called Combine Two Tables. And if I look at the companies this question has been asked in, so Apple, Bloomberg, Amazon, Microsoft, Adobe, Google, a number of times. Kind of an important question. Let's look at what the question has to say. We are given a table called person with three different columns: person ID, last name, and first name. Person ID is the primary key, that is column with unique values for this table. This table contains information about the ID of some persons and their first and last names. We are also given a second table called address with 4 different columns: address ID, person ID, city, and state. Address ID is the primary key, that is column with unique values for this table. Each row of this table contains information about the city and person of one person with the ID is equal to person ID. We are asked to write a solution to report the first name, last name, city, and state of each person in the person table. If the address of the person ID is not present in the address table, report null instead. Order of the result does not matter. Okay, so let's go through this example. So here we have two persons following addresses in the address table, and we need for every person in the person table the first name, last name, city, and state. So for person ID 1, that is Alan Wang, do we have a address in address table? Since in address table we only have addresses for person ID 2 and 3, so we do not have address for Alan Wong. So here the city and state column should be null and null. For Bob Alice, since the person ID 2 is available in address table, so here we can have New York City and New York. So that is what we have in our output. So we learned in SQL 50 series that whenever the language of the question is for every person in a person table, right? So that means you need to keep everything from the person table, and you also need in our output a columns from another table. That is, it is an example of an outer join, that you keep the information from the table that you have, one of the tables, and then you reach out to another table to get information from that. So this question can be solved using the left outer join, or in short what we call left join. So from the table called person, because we need to keep every person in the person table, let's alias this as P. Left join, that is you reach out to the address table, address aliased as A, and which column we are going to join these two tables on, since we have person ID in the person table as well as the address table. So P dot person ID is equal to A dot person ID, right? And also in our output, what do we need? We need the first name, p dot first name. Then we also need the last name, so p dot last name. Then we need the, in our output, city and state, which comes from the address table. So a dot city and a dot state. Okay, now another thing that is mentioned here is that if the address of a person ID is not present in the address table, report null instead. So to not be confused by this statement, because actually how this join work. So here it says, okay, we are doing from person left join address on person ID equal to person ID. So here it says, okay, person ID, it will go and try to find out an address table. But if it won't find anything, so it will by default return nulls in the columns that are coming from the address table. So you do not have to do anything extra, right? So don't get confused by this statement. So let me go ahead and run this and let's see what do we get in our output. Okay, why did we get a runtime error? Because when we are joining, we need to use the on clause that we missed. Okay, on this, and then let me go ahead and run this. Let's see what do we get. Yeah, so this is accepted. Our output, let me just drag it to the left so this is easier for us. Okay, and if we look at our output, right, so our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how to do it. Not a very difficult question, but we had to use our knowledge from the SQL 50 series that, okay, here we need to keep every person from the person table and reach out to the address table to get the city and state columns. So that is why we performed a left join. We use the person ID column because that is present in both of this and mean the same thing, right? Just being present with the same name in both the table does not guarantee that they have the same information. And yeah, and we return the columns that are required in our output. So this is the seventh video of the series called Sellers with No Sales, and let's look at what the question has to say. We are given a table called customer with two different columns, customer ID and customer name. Customer ID is the column with unique values for this table. Each row of this table contains the information of each customer in the web store. We are given a second table called orders with five different columns: order ID, sale date, order cost, customer ID, and seller ID. Order ID is the column with unique values for this table. Each row of this table contains all orders made in the web store. Sale date is the date when the transaction was made between the customer, that is customer ID, and the seller, that is seller ID. We are also given a third table called seller with two different columns, seller ID and seller name. Seller ID is the column with unique values for this table. Each row of this table contains the information of each seller. We are asked to write a solution to report the name of all sellers who did not make any sales in 2020. Return the result table ordered by seller name in ascending order. Okay, let's go through this example. So here we have the customer table, then we have the orders table. Let me drag it to the right so that it's easier for us to read. And then we also have the seller table. So for each of the seller, we need to find out who did not have a sale in year of 2020. So we have three different sellers, Daniel, Elizabeth, and Frank, with seller ID 1, 2, and 3. So for 2020 in the orders table, we only have three rows, right? So row number 1, 2, and 4. And what is the seller ID associated with it? So 1, 2, and 2. So obviously 1 and 2, that is Daniel and Elizabeth, had sold something in 2020, but Frank has not sold anything in 2020. So that is what we have in our output. So we have learned earlier in the series as well as in the SQL 50 series that we completed before this for beginner and intermediate level SQL problems, that whenever we have the language of the problem, like for every seller in a seller table, right? So basically it is asking us to perform an outer join on the table that we need to keep everything from, and then reaching out to something else. So here when it says all the seller from the seller table, right? And we need to make sure that the orders table, the row that we are considering is on where the year of sale date is 2020. So what we need to do is, let me, for example, let me drag it to the left and make sure that, okay, from this table called seller, right? Let me just drag it down. Okay, so from the table called seller, let me alias this as S, and I need to perform a left join because I need for every seller need to find out whether they were selling something in 2020 or not. Left join. But now from the orders table, I am only interested in those rows where the year of sale date column is equal to 2020. So what I can do is I can do that. Okay, from this table called orders, right, from this table called orders, I need to keep only those rows where year of the sale date column is equal to 2020, and for those rows, I need to keep all the columns. Okay, so select star. And what I can do is I can, alias this entire thing. This entire thing basically becomes, this entire thing is a table that will only have rows where your year is equal to 2020. So basically these three rows. Okay, so what I can do is let me alias this as T or O or whatever, or let me just alias is that O. Now I need to left join on, so on S dot seller ID is equal to O dot seller ID, right? So if I just drag it to the right, so we can see that, okay, S dot seller ID is equal to O dot seller ID. So basically what we are doing is for every seller, we are trying to find out the orders that were made in 2020 associated with them. So obviously if you have this, right? So for seller ID 3, so in the rows where year of sale date is 2020, this is not going to find any match. So all the columns coming from the orders table is going to have nulls in them. So if I go ahead and do select star and let me go ahead and run this, let me drag it to the left. So let's see what do we get in our output. Okay, so if I look at our output, so this is what we have. And if we can see for Frank, we have nulls because there was no order made in year 2020. So obviously we need to return all those rows where any of the column value coming from the table that we created is null. So we need to keep only those rows where O dot order ID is null. You can choose any of this, but since the question says that for 2020 which seller did not make any sale, so obviously I'm taking the order ID as null. Okay, so if I go ahead and run this, then it will keep only that particular row, that is for Frank, right? So this is the person who has not sold anything in 2020, but in our output we only need the name of the seller. So what we can do is we can simply go ahead and do s dot seller name. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so even though this says accepted, our solution is not complete because our output, even though it says is same as expected output, we actually need to order this by the seller name as well. So if we look at our question, if it is, there are more than one person who has not sold anything in 2020, we need to order this by, so order by s dot seller name, and by default it's arranges in ascending order. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Not a very difficult question. All we had to do was, we learned about this concept that whenever the language of the question is that for all the sellers who did not make any sales, so basically it is an example of using a outer join. We used a left outer join, and before performing a join on the orders table, we were only interested in those rows where year is equal to 2020 because that is what the question is asking us. We performed a join and then kept only those rows where order ID is null, basically which satisfies that sellers who did not make any sales in 2020, and then we return the seller's name and ordered by seller name in ascending order. So this is the 8th video of the series called Top Travelers, and if I look at the companies this question has been asked in, so point 72, let's look at what the question has to say. We are given a table called users with two different columns, ID and name. ID is the column with unique values for this table. Name is the name of the user. We are also given a second table called rights with three different columns, ID, user ID, and distance. ID is the column with unique values for this table. User ID is the ID of the user who traveled the distance. We are asked to write a solution to report the distance traveled by each user. Return the result table order by travel distance in descending order. If two or more users travel the same distance, order by their name in ascending order. Okay, let's look at this example. So here we have multiple users and their rights. So what we need to basically do is we perform a join of users table because it says, the question says for every user we need to calculate the total distance. So what we can do is we can perform a outer join because we have learned in our previous videos in this series as well as the SQL 50 series that whenever the language of the question is that keep everything from one table and have something else to be done using another table. So it's best to do a outer join. In this case we can use the left outer join, right? So here we can perform a join on id column of users table and user id column of the rights table, and we will get that okay, these are the distances covered by each of the users, and then we can group by the id, the name, and sum the distance part, and that is what we have in our output, and we can arrange them in descending order. Also, another thing that to note here from this output is that for Donald it says 0. So Donald is id 4, and if you look at id 4 there is nothing. So actually if you perform a join, it is going to return you null. So we also need to use the if null function, that if something comes out to be null at the end, then you need to replace it with 0. Okay, let's try and write the query for this. So what we need to do is, from this table called users, because we need it for every user, alias this as u, left outer join, or we should call it left join, the rights table aliased as r on u dot id is equal to r dot user id, and let me keep the columns, all the columns from the users table u dot star, but we are only interested in the distance part from the rights table, because that is what we need, the total distance covered by each of the users. So let me keep only that column, and let me go ahead and run this. Let's see what do we get in our output. Okay, let me drag it above. So here we have for each of the users multiple distances that were covered by the person. That, for example, if you to take Lee, right? So if you group by the use ID, so for Lee, if you sum this part, so that is going to give you the total distance traveled by Lee. Similarly for Elvis and all the people. So what we need to do is, now we can go ahead, because for every user it says the total distance. So we can group by the ID and then the name. Why? Because it says in this column, in this table, that ID is the column with unique value. So if you directly, because in your output you need the name, you do not need the ID. But just think about this. If you directly go ahead with grouping by name, it is possible that person with the same name can have different ID, right? So there could be multiple people with the same name. So if you directly go ahead and group by the name, that is going to give you an error. So what we need to do is, we need to group by u dot id, because these two columns are coming from the users table. So u dot id, and then do u dot name, because we need u dot name in our output, and we need to use this r dot distance to sum this up. So sum the entire thing, and then if yeah, you are summing this up. So let me just go ahead and further, this is what we need as traveled distance. So let me just copy this and let's alias this as, so as traveled distance, and let me go ahead, and also we need to order this by travel distance in decreasing manner. So if I go ahead and write order by traveled distance in descending manner, and in case there is a tie, then by name. So u dot name in ascending order. Let me go ahead and run this, and still not complete yet, but let's try to go step by step. So here if I look at our output, so here we can see that for Daniel it's null, right? But in our output we need it 0, right? So what we need to do is, we need to basically do that. Okay, if you, after you sum this distance and it comes out to be null, then you can use the function if null, this comes out to be a null, then replace it by something, and here we need to replace it by 0. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how to do it. It was basically performing a outer join, and then we use the left outer join here, because for every user we need to reach out to the rights table to get the total rights and the distance covered in each of those rights, and then we group by the ID and the name, and we learned why do we do that, even though we do not need the ID in our output, so that our groups are correct, and then we sum the distance part and also use the if null function that we have learned already. that if the entire thing comes out to be null, you replace it by 0, and then we ordered by travel distance in decreasing manner, and in case of a tie, by name in ascending order. So this is the ninth video of the series called salesperson. If I look at the companies this question has been asked in, so Uber a couple of times in last 1 year, so kind of an important question. Let's look at what the question has to say. We are given a table called salesperson with 5 different columns: sales ID, name, salary, commission rate, and hire date. Sale ID is the primary key, that is column with unique values for this table. Each row of this table indicates the name and ID of the salesperson alongside their salary, commission rate, and hire date. Another table is company with 3 different columns: com ID, name, city. Com ID is the primary key for this table. Each row of this table indicates the name and ID of a company and the city in which the company is located. We are also given a third table called orders with 3 different columns: order ID, order date, com ID, sales ID, amount. Order ID is the primary key for this table. Com ID is a foreign key, that is a reference column to the com ID from the common company table. Sales ID is the foreign key for the salesperson table. Each row of this table contains information about one order. This includes the ID of the company, the ID of the salesperson, the date of the order, and the amount paid. We are asked to write a solution to find the names of all salesperson who did not have any orders related to the company with the name read. So just read the language of the question. All salesperson. So we need to do a outer join, just like we did in our previous video. Outer join of the salesperson table on the orders and then on the companies, because the way to join salesperson table with the orders table is through the sales ID, and then since we also need the name of the company, so we need to join this orders table using the com ID column with the com ID column of the company. Okay, return the result in any order. Let's go through this example and see what do we need in our output. So here, if we look at it, so we have 5 different salesperson and various companies, and these are their orders. So which all salesperson do not have any orders related to the company read? So if I look at John, right, so John sales ID 1 has one order, right, which is related to com ID equal to 1. Com ID 1 is read, so John should not be in our output because John has the order related to company read. Similarly, if I go and find for Amy sales ID is 2, so for sales ID 2 there is nothing, so obviously there is no order, so Amy should be in our output. For Mark sale ID 3, for Mark sale ID 3, again nothing, so Mark should also be in our output. Pam, if I look at sales ID 4, 2 different orders for company ID 3 and 1. So 3 is yellow, but 1 is red. So the person has one order from the red. So Pam should not be in our output. And for Alex 5, so we have one order for company ID 4, that is green. So no order from the red. So in our output, we should have Amy, Mark, and Alex. And that is what we have in our output. So since we already established that we need to perform an outer join because we need to keep every person from the salesperson table. So what we can do is we can do from this table called salesperson, let's alias this as S, left join the orders table, because the only way this table can be joined is to orders table. You cannot join this table directly to the company table because there is no common column. So orders table aliased as O on S dot sales ID is equal to O dot sales ID, O dot sales ID. And since we also need the name of the company, so we also need to make sure that we left to join the company table aliased as C on O dot company ID is equal to C dot company ID. Okay, and let me keep on, because if I keep all the columns, there would be a lot of redundancy and it would be very wide table. So let me just keep the required column. So return. So since a sales ID is the primary key, and just like we explained in our last video, that whenever you are, whenever you need the names of the people, because if in your output you need the names of the people, names can be same, right? For 2 different people, names can be same, but a unique identifier would be unique. So always keep a unique identifier whenever you need this kind of output. So S dot sales ID, because sales ID comes from the salesperson table. Then we also need the name, so S dot name. Then of only thing that we are concerned with is the name of the company. So we can go c dot name, and if we want we can just keep the order id just to make sure that whether there was some order or not, although we do not need anything from this, but like let's just keep it. So o dot order id as well. Okay, let me just drag it to the left so that it's easier. Okay, and let me go ahead and run this, and let's see what do we get in our output. So if I look at it, so I have in our output the sales ID, the name of the person, this is the name of the company, and the order ID. Obviously, as we saw for Amy and Mark, there was no order. So nulls and nulls. And then for Pam, there was two orders, one from yellow, one from red. And for Alex, only one order. Similarly for John, only one order, but that is from red. So just by looking at it, what do we need in our output? Amy, Mark, and Alex. So from this moment, you can either take the common table expression route. And how can you do that using common table expression? So what you can do is you can save this in a common table expression, right? So this entire thing is saved into common table expression. And then you simply say that, okay, find the sales id of the people who has ordered from a company called red, and exclude them from the sales ids, and obviously whatever you are left with, that is going to give you the names of people who have not ordered anything from the company called red. But there is a smarter way to do that. How? Here the question says that any person who has ordered from the company called red, that should not be in our output. So what if we assign the names red as value 1 and everything else as 0, and then we group by the sale id and name and try to sum up that values that we are assigning. So let me just, firstly let's do this. So let me use the if function. So if the name and the name columns come from this name is basically the company name. So if c dot name is equal to red, then you assign the value 1, else you assign the value 0. And let me alias this as, let's say, let's create this as a flag. Let me go ahead and run this. So what I'm saying is, if you look at this, so here, if you group by the sale ID and name and sum this flag, so what would the sum of flag be for John? It would be 1, which means that the person has ordered from a company called Red. What would be the sum for Amy? 0. Mark? 0. What would be the sum for Pam? 1 plus 0, that is 1. Again, because this person has ordered something, so that should not be in our output. Similarly, for Alex, that would be 0. So it would be 0 for only those people who have not ordered anything from Red, right? So what you can do is you can apply this logic. So you can group by the s dot sales id. Again, the same logic that a sales id is unique, names can be similar for two people as well. So even though you need name in your output, make sure that you group by sales id first, otherwise you might not pass certain test cases. So group by this, and then having, right, because we need the aggregate filter based on an aggregate, that is sum of the flag. So having sum of the flag is equal to 0. Now what is the flag that we created? Because in our out, since we are grouping by only sales id and s name, right, so we cannot have all these columns in our output. You cannot do that. So what you need to do is, by this flag you can simply replace this flag by this, right? So let me just cut this part here and have this is basically doing the same thing. And then let me return, okay, so we need sales id and sales name. Okay, so if I go ahead and remove this, and since we are grouping by sales ID and sales name, we can have that in your return part. Let me go ahead and run this. Let's see what do we get in our output. Not yet complete. That is why it says wrong answer, but let's see what do we have in our output. So now we are only left with those people who have no orders from company called Red. In our output, we do not need the sales ID. We only need the name, and there should not be any alias to the column. So simply we can go ahead and remove the sales ID part. So yes, we are grouping by, but it is possible that you do not return that. Right now, let me go ahead and run this. Let's see what do we get. So now this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. This is accepted, and this is how we do it. So not a very difficult question, but yeah, tricky because you have a lot of tables and you need to make sure that you join in the correct manner so that for every salesperson you are able to, calculate whatever is required in your output. And we use a better way. You can do this again by common table expression. Let me know if you know about common table expression. Let me know how the solution will look like in the comment section below. So this is the 10th video of this series called Evaluate Boolean Expression. And if I look at the companies this question has been asked is, so 0.72. Let's look at what the question has to say. We are given a table called variables with two different columns, name and value. In SQL, name is the primary key for this table. This table contains the stored variables and their values. There is another table called expressions with three different columns, left operand, operator and right operand. In SQL, left operand, operator and right operand is the primary key for this table. This table contains a Boolean expression that should be evaluated. Operator is an enum that can take one of the values less than, greater than or equal to. The values of left operand and right operand are guaranteed to be in the variables table. Okay. Evaluate the Boolean expressions in the expressions table. Order of the result does not matter. So here we have x and y's and their values, and in the expressions table we need to check whether x is greater than y, less than, equal to. Similarly, y is greater than x, y is less than x, and x is equal to x, and things like that. The value of x is 66 and y is 77. Is x greater than y? No. So here it should return false. Is x less than y? Yes. So it should return true, and so on. And that is what we have in our output. Okay, so the first thing that we need to do is, since in the expressions table we have the operands, firstly we need to perform a join, but here just by doing one join won't suffice. So the first thing that we need to do is, from this table called expressions, let's alias this as E. Let me left join the variables table aliased as v1, and there is a reason why we are aliasing this as v1, on E dot left operand is equal to v1 dot name, and in the output what we can do is return star. So let's keep everything from the expressions and then have the, because we only need the value of these ones, right? So we can write v1 dot value, and let's alias this as left operand value, right? Left operand value. Let me go ahead and run this. Let's see what do we get in our output. So if we look at it, so in our output we have the values of x's and y's populated, right? Now similarly we can do for right operand, and you might think that okay, you can do this simultaneously. So some of you might be thinking that instead of doing this, what if we simply go ahead and write and e dot right operand is equal to v1 dot name. So this is going to be a problem. Why? Because here if you use and, so that is going to give you that it will check both of these conditions before performing a join. So if I run this, let's see what do we get. So you see here you are getting nulls. So that is why you cannot do this. So what we need to do is we can perform the same thing again as well, but this time for right operand. So left join variables, this times alias this as v2 on e dot right operand is equal to v2 dot name, and we can have v2 dot value as right operand value. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so now if we look at it, so now we have the left operands and right operands. Now we can simply go ahead and compare these based on the operator. So what we need is, so let me go ahead and do this. So case when, so case when operator belongs to greater than, right? So operator is equal to greater than, then what you do is, then you simply compare left operand value is greater than right operand value. So you can do left operand value is basically what? v1 dot value. So let me just copy this. So then this is greater than v2 dot value. So this is what we need to check, right? Then similarly, when operand is, or when operator is equal to less than, then what you need to do is you can simply go ahead and copy this and just change the sign. So here v1 dot value should be less than, this is what you need to check. And when operator is equal to, right? So let me just copy this entire thing so it would be easier for us. When operator is equal to, then you check for the equality, right? And then even if you do not write else, it will take null, but you can just simply write else null. Since you started a case when statement, you need to end, and let's alias this as whatever is required in our output, right? So this is not yet complete, but let's see. Okay, so this column is going to be called value, so end as value. Okay, let me go ahead and run this. Let's see what do we get in our output. So let me drag it to the left and drag it above. So here we can see that, okay, here we have zeros and ones instead of false and true. So what we can do is we can use the if statement to basically substitute these zeros and ones with false and true. So what we can do is, so let me do this for one of the cases first, and it will, tell you that, okay, what we are trying to do. So if so here for this particular, right, so x greater than 66 greater than 77, so obviously this is not true, so it is returning a value 0. So if this condition, after evaluating this condition, you are getting a value called, right, so if after evaluating this condition you are getting that, okay, hey, this is coming out to be 0, then you replace it by false, else you replace it by true. Okay, let me go ahead and run this now. I need to do this for all this, but like, just want to show you that, you see, those zeros and ones are for these particular greater than operators are replaced by false and trues. Similarly, you can do the same thing for this one as well. Okay, so let me go ahead and run this. Let's see what do we get in our output. So here we have all those values, and obviously these are the two columns that we do not require in our output, right? We do not need this in our output. So what we can do is we can simply go ahead and remove these two. So remove these two columns, and if I go ahead and let me just drag it down. So this is the entire solution, how it looks like, right? And let me go ahead and run this. Let's see what do we get in our output. Okay, so let me, drag it above. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. Yes, somewhat tricky question because here you need to evaluate Boolean expression. So what we did was, firstly, we used the expressions table to get the values associated with the variable names, right? And then we had to do this twice because we can only do that one at a time. And then once we had those values, left operand value and right operand value, then what we are doing is we basically compare. And then since after comparing we are ending up with zeros and ones, but in our output we need trues and false. So what we did was we used the if function to check that if this is satisfying a particular condition, replace it with something else. If not, replace it with something else. Okay, so this is the 11th video of the series, team scores in football tournament. And if I look at the companies this question has been asked in, so Wayfair, kind of an important question. Let's look at what the question has to say. We are given a table called teams with two different columns, team ID and team name. Team ID is the column with unique values of this table. Each row of this table represents a single football team. We are also given a second table called matches with 5 different columns: match ID, host team, host goals, and guest goals. Match ID is the column of unique values of this table. Each row is a record of a finished match between two different teams. Teams, host team and guest team are represented by their IDs in the teams table, team ID, and they scored host goals and guest goals respectively. You would like to compute the scores of all teams after all matches. Points are awarded as follows. A team receives 3 points if they win the match, that is scored more goals than the opponent. A team receives 1 point if they draw the match, that is scored the same number of goals as the opponent team. Team receives no points if they lose a match, that is scored fewer goals than the opponent. We are asked to write a solution that selects the team ID, team name, and number of points of each team in the tournament after all the described matches. Return the result table ordered by number of points in decreasing order, and in case of a tie, order the records by team ID in increasing order. Okay. Let's go to this example because the question is very lengthy, but let's see, right? So for example, let's do for team ID 10, that is Leetcode FC, and see after all these 5 matches, what is the score they are standing at. So team ID 10 has played what? Match 1 as a host team, match 2 as a guest team, and match 3 as a host team again. And these are the three matches. Now in match one, the host scored 3 goals and guest scored 0. So obviously who won? The host team. That is Leetcode FC won this, and here the points awarded is going to be 3. Now for match ID 2, Leetcode FC is a guest team and they drew the match. So here the points is going to be 1. So 3 plus 1 right now is 4. And then again host team, and they scored 5 as compared to the guest one who only scored 1. So obviously they again won. So 3 points here as well. So 3 plus 1 plus 3, so 7. So at the end of all these matches, Leetcode FC is standing at 7 points. Similarly, you can do that for team ID 20, 30, 40 and all that. So here if you look at it, right, and then we arrange by number of points in descending manner in case of a tie by team ID in ascending order. So you see Leetcode FC ended up with 7 points. So that is what we need to do in this case. So just like we described right now, what we can do is for every team in the teams table, what we can do is we can try to find out, okay, what are the different matches the team was involved in, either as a host team or a guest team. So okay, team ID 10, that is Leetcode FC, is involved in match ID 1, 2 and 3. Then we can calculate, okay, whether the host won, whether they drew, whether they lost, etc. So the first thing that we should do is we should perform a join of teams table on matches table. So perform a left join, that is reach out to the matches table to see what all matches each of these teams are involved in. So what we can do is from this table called teams, let's alias this as T. Let me left join the matches table M on. Now your team can be either a host team or a guest team. So on T dot team ID is equal to M dot host team, or you can have T dot team ID is equal to M dot guest team. Okay, and let me go ahead and do select star to see what we need in our output. Okay, so if I just drag it to the left and let me go ahead and run this, let's see what do we get. Okay, so if we look at our output, let me just drag it to the left more and above. Okay, so here for every, so we saw that, right, Leetcode FC is involved in 3 matches, match ID 1, 2 and 3. So whether they were the host team or the guest team, and then the host goals and guest goals, right? So let me switch to Excel so that I can display this in a graphical manner. So here you had the teams table and the matches table, and we perform this join of these two tables on either the team can be host team or can be guest team. So this is what we ended up with, right? So for every team we have, okay, what are the matches they are involved in, who was the host team, who was the guest team, host goals and guest goals. And now once you have this, then you can simply go ahead and add a column called points for every match the team is involved, whether they get 3 points, 1 point or 0 point. So for example here, how many points Leetcode FC should get? They were the host team and the host scored more than guest, so obviously they won. So here the point should be 3. Similarly here, since the match was draw, so 1 point. Here again 1, so 3. For New York FC in match ID 1, so they were the guest team and guest scored less than host. So here they should get 0 points. For New York FC match ID 4, they were the host and host scored more than the guest. So here they should give 3 points. Similarly, we can do that. So what we can do is we can perform a case when statements that, hey, if the team ID is the host team and host scored more than the guest, then you get 3 points, because if you are a host and host is scoring more, then you won. If you are a guest team and guest is scoring more, then again you also get the 3 points because you won. If you are a host team or a guest team and number of host goals and guest goals are equal, then you get 0.1. In all other cases, you get the 0.0. Why? Because what are all other cases? First case is you are the host team but guest score more. So obviously you lost the match, you get 0.0. You are the guest team and host scores more. So again you lost the match, so again you get 0. And then there are cases like Chicago FC where you are not playing any match. So obviously at the end of the tournament, you are going to be at 0 points. So we can go ahead and do this. So here, let me just, okay. So let's do case when you are the host team, right? So case when T dot team ID is equal to m dot host team, and so firstly you are the host team, and m dot host goals are greater than m dot guest goals, then you receive 3 points, right? Similarly, let me just copy this because it is just typing the same thing with just slight changes. Then what is happening is, if you are the guest team, right? If you are the guest team and guest goals are more than host goals, so then again you won and you get 3 points. Now actually it should not be case when, it should start with when. Okay, now what happens is there is a possibility of being drawn, right? So in that case what happens is, so either you are a host or a guest, it does not matter, but if your number of goals are equal, then obviously it is going to be a draw and you get points 1. In all other cases, so else you are basically losing the match or not playing the match. So else you get 0 and end as, let's alias this as points. Okay, let me go ahead and run this. Okay, so if we look at the number of points, let me just drag it to the left more and above. Okay, so now we have, for every match this particular team is involved, how many points they get. So here they won, so 3, draw 1, again 1, 3, here they won, so 3, lost, so 0, and so on. So obviously now once you have for every team and the number of points, then all you need to do is group by the team ID and the team name, because you need that in your output, and sum the points and order by decreasing manner, right? Because that is what is left. So if I switch back to Excel, so here what we did was we added the points column using this, again same thing. If you are a host team and host is more, then you win. If you are a guest team and guest scores more, then 3. If it is a tie, then you get 1, else you get 0 and ends points. So we added this points column, and then what we do was basically this entire thing, right? So this is what we have right now. Right now what we can do is we can either save this in a common table expression, temporary table, etc. But if you know that, you can simply go ahead and do that, or what you can do is you can simply put this entire thing, right? So whatever code right now you have, this entire thing is basically producing, this entire code is basically producing this table, right? So what you can do is from, right, so from what you can do is from this entire thing, because this entire thing is producing the table that we have, and let's alias this as table T. What you can do is now simply go ahead, group by the team ID and the team name and sum the points. So what we do is group by T dot team ID is, and then T dot team name, and then what we do was is return T dot team ID, T dot team name, and what we need was is the sum of T dot points. And let me alias this as whatever is required in our outputs. I think it is number of points. Let me just drag it to the right. Let's look at what our output looks like. Okay, yeah, so it should be number of points. Okay, so here this should be number of points. Okay, I think this looks good, and we also need to order by number of points in decreasing order, and in case of a tie by team ID in increasing manner. So let me just drag it to the left, and at the end what we do was order by number of points in decreasing manner, and in case of a tie, T dot team ID in increasing manner. Okay, let me just drag it down. So this is how the entire code will look like. Let me go ahead and run this. Let's see what do we get in our output. So if I drag it above, we can see that this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, if we look at it, this is accepted. This is how the solution looks like, right? So it's kind of a long solution, but this flowchart will tell you that, okay, what we did was firstly, what are the matches the team is involved in. Then when we had that, then we calculate, okay, for every match the team is involved in, how many points they were able to get out of it. We created the points column, and then we simply grouped by the team ID, team name, and the number of points. we sum that and arrange this in decreasing manner. So this is the 12th video of the series called latest login in 2020, and let's look at what the question has to say. We are given a table called logins with two different columns, user ID and timestamp. The combined column user ID and timestamp is the primary key, that is combination of columns with unique values for this table. Each row contains information about the login time for the user with the ID user ID. We are asked to write a solution to report the latest login for all users in the year 2020. Do not include the users who did not log in 2020. Order of the result does not matter. So here we have certain user IDs and the timestamp of their login. So for every user we need in 2020, what is the latest login? That is the last login. For user ID 6, we have three different rows, but there is only one login in 2020. So obviously that is going to be the last login in 2020. Similarly, for user ID 8, we have two different logins, but the last login was on 30th of December 2020. Similarly, for user ID 2, one login, so this one, and for user ID 14, since there is no login in 2020 and the question says to exclude those rows, the only thing that we are going to have in our output is user ID 6, 8 and 2, and that is what we have in our output. So not a very difficult question. What we need to do is we need to use the aggregate function maximum. So from this table called logins, if we keep only those rows where the year of the timestamp column is equal to 2020, because that are the only rows that we are concerned with, because that is what the question says. And then once we have this, right, so let me just do select star so that we know that okay, we are only going to keep those rows where the year part of the timestamp column is equal to 2020. So if I look at our output, so now we are only left with the 2020 logins. Now you can simply go ahead and group by the user ID and find the maximum timestamp, because that is going to give you the latest login in 2020, right? So that is the maximum timestamp. So what we can do is we can simply go ahead and group by the user ID and return the user ID and then get the maximum of timestamp column, and that is going to be the that is what is required in our output, last stamp. So last stamp. Let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Not a very difficult question. All we had to do was firstly we kept only those rows where the year of the timestamp column is 2020, because that is what the question directs us to do. And then we grouped by the user ID, and to find the latest login we simply use the max function and alias this as last time. So this is the 13th video of this series, gameplay analysis part 1. And if I look at the companies this question has been asked in, so Adobe, Amazon, Bloomberg, JSN Games, a number of times. Very important question. Let's look at what the question has to say. We are given a table called activity with 4 different columns: player ID, device ID, event date and games played. The combined columns player ID and event date is the primary key of this table. This table shows the activity of players of some games. Each row is a record of a player who logged in and played a number of games, possibly 0, before logging out on some day using some device. We are asked to write a solution to find the first login date for each player. Order of the result does not matter. Okay, let's go through this example and see. So here we have different data for different players. So player ID 1, what is the first login date? Obviously 1st of March 2016. For player ID 2, since there is only one row, so obviously this is going to be the first login date. For player ID 3, the first login date is going to be 2nd of March 2016. And that is what we have in our output. Again, very similar to the previous question. What we need to do is we want the earliest login. So we need to use the minimum function. So from this table called activity, we can group by the player ID, group by the player ID and return player ID and the minimum of the event date, that is going to give you as first login. So as first login. Okay, since we do not need to order this by anything, let me go ahead and run this. Let's see what do we get in our output. So this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Not a very difficult question. All we had to do was we grouped by every player ID, and then what we did was we found the minimum of event date, because that is going to give you the first login date, and we got the solution. So this is the 14th video of this series called Warehouse Manager. And if I look at the companies this question has been asked in, so Amazon, kind of an important question. Let's look at what the question has to say. We are given a table called warehouse with 3 different columns: name, product ID and unit. units. The combined column names and product ID is the primary key combination of columns with unique values for this table. Each row of this table contains the information of products in each warehouse. We are also given a second table called products with 5 different columns: product ID, product name, width, length, and height. Product ID is the primary key, that is column with unique values for this table. Each row of this table contains information about the product dimensions, that is width, length, and height in feet of each product. We are asked to write a solution to report the number of cubic feet of volume the inventory occupies in each warehouse. Order of the result does not matter. So here we have 3 different warehouses and different product IDs stored in each of them and the number of units, and then for each of those products what is the name of the product, width, length, and height. So obviously what we need to do in this case is, for every warehouse we can perform a left outer join and try to reach out to the products table to get the width, length, and height, so that we can multiply the number of units with width, length, and height, because for one particular unit what is the volume occupied, width multiplied by length multiplied by height, and then you multiply it by the number of units, that is going to give you the total volume occupied by that product in that particular warehouse, and then you group by the warehouse and sum the entire volume. So what we can do is, from this table called warehouse, aliased as W, if I go ahead and left join the products table aliased as P on W dot product ID is equal to P dot product ID, and let me go ahead and keep all the columns just for demonstration purposes to see what we need in our output. So if I go ahead and run this and let me drag it to the left and to up, and if I go ahead and look at our output, so now we have for every warehouse and the product ID the name of the product, width, length, and height. Okay, so to calculate the volume, we need to basically do number of units multiplied by width multiplied by length multiplied by height. So if I go ahead and calculate, okay, so if I do number of units is coming from the warehouse, right? So W dot units multiplied by P dot width multiplied by P dot length multiplied by P dot height, and this is going to give you the volume, right? So as volume, let me go ahead and run this. Let's see what do we get in our output. So now if we look at it, so now we have a volume column that, okay, in this warehouse LC house 1, this product ID 1, which is the LCTV, since the number of units is only 1, this total volume occupied is 10,000 cubic feet. Similarly, in LC house 1, for product ID 2, that is a keychain, there are 10 different units, so the total volume occupied is 1250 and so on. So once you have this, then what we can do is, for every warehouse we need the total volume. So we can go ahead and do group by, right? So group by the name and W dot name, and you can return W dot name and whatever you get, right? So this is the entire volume. You basically sum this up. So sum this entire thing is going to give you the total cubic feet volume occupied by all the products in a particular warehouse. And if I look at the output, so I think this should be renamed to warehouse name. So as warehouse name, let me bring this down so that it's easier for us to visualize. Okay, so let me drag it to the right. Okay, so this is the solution. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. This is accepted, and this is how we do it. Not a very difficult question. All we had to do was we had to reach out to the products table so that we knew the width, length, and height of each of the products in the warehouses, and then we simply calculated the volume by multiplying units with the width, length, and height, and then we grouped by the warehouse name and summed that entire volume to give the total volume occupied by all the products in a particular warehouse. So this is the 15th video of the series called customer placing the largest number of orders, and if I look at the companies this question has been asked in, so Adobe, Google, Apple, Uber, Twitter, a lot of times. So kind of an important question. Let's look at what the question has to say. We are given a table called orders with 2 different columns, order number and customer number, and both of them have a data type integer. Order number is the primary key, that is column with unique values for this table. This table contains information about the order ID and the customer ID. We are asked to write a solution to find the customer number for the customer who has placed the largest number of orders the test cases are generated so that exactly one customer will have placed more orders than any other customer. Let's look at the example. So here we have various different orders and different customer numbers. So obviously just by looking at it, customer number 3 has order 2, which is more than every other customer. So in the output, you need to have that. So just by looking at it, right, and looking at this statement, the test cases are generated so that exactly one customer will have placed more orders than any other customer. So we can simply go ahead and group by the customer number and then count the number of orders and then order in descending manner and say, okay, because there can be only one customer that will have the maximum order, you can just limit the output to 1. But that is a very hard code or way of doing this solution, because if you look at the follow-up of this, it's asked, what if more than one customer has the largest number of orders? Can you find all the customer number in this case? So let's try to develop a solution which can address both of this in one single query. So the first thing that we should do is, for every customer, we can try to count, okay, what is the different number of orders for them. So what we can do is, we learned about window functions in previous videos of this series, right? So what we can do is, from this table called orders, we can keep both the columns, select star, and then try to find out, okay, since we are using a window function, we need to write the over clause, and then what we can do is, for every customer number, we need to find out the total number of orders. So partition by customer number, and then what we need to do is, we need to count the order number, and since order number is a primary key, so obviously you do not need to write distinct before that. So count the order number, so that we are able to, okay, let me just bring it down so that it's easier for us. Okay, and let me alias this as count. So this is going to give you, for every customer number, what are the different number of orders made. So if I go ahead and look at it, so here we have, let me drag it above. So for customer number 1, there is only one order. So one. Customer number 2, one order. Customer number 3 has 2 orders, right? So 2 is populated. Once we have this, then what we need is, we need which customers ordered the maximum number of orders. So basically what we can do is, we can use the rank, right? We'll remember, we learned about row number, rank, dense rank, etc. functions earlier in this series as well. So we can employ that. What we can do is, so this entire thing is coming from this, right? So this can be classified as a table. So from this table, and let me call this table as counts, because here we counted, okay, for every customer number, how many total orders there were made. From this table called counts, what we are doing is, let's try to rank. So return star to keep all the 3 columns and then rank. Now we know that there are 3 different ways of ranking in SQL: row number, rank, and dense rank. Here row number won't work, but what if there is a customer number 4 who also have 2 orders? So row number, irrespective of being a ties, it will assign a different rank, so it won't work. So either you can use rank or dense rank. I like to usually use dense rank because it's like, it makes more sense, but yeah, you can perfectly use rank here and get the solution as well, no problem. So over, and then we need to order by count, in decreasing manner, and let me alias this as rnk, which is rank. Let me go ahead and run this. Let's see what do we get in our output. So now if you look at it, so obviously this customer number 3, because this customer has the highest count of orders, so is ranked 1, and then 2, because both of them has number of orders equal to 1. So this is how we get. Okay, now what we need is, we need the people with the highest number of orders. So obviously rank equal to 1 is assigned to those who have the highest number of orders. So what we can do is, from this entire thing that we just got, so from this entire thing, we can alias this as, or name this table as, let's say, ranks. What we need is, we need to keep only those rows where your rank is equal to 1, which means the highest number of orders. And then what we need in our output is, we need only the customer number. But if you look at it, if you just do return customer number, it will have 2 rows. So we need only the distinct customer numbers. So we can simply go ahead and write return distinct customer number, Right, and let me go ahead and run this. Let's see what do we get. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how to do it. Okay, so this is a generalized way of doing this question, right? Instead of using limits and everything. And how general this solution is, like if they ask us, okay, what is the second highest order? All you need to change in this is rank is equal to 2, right? So that is why developing a general solution is a way better method than trying to hard code things. So this is the 16th video of this series called find total time spent by each employee. And if I look at the companies this question has been asked, Adobe and Amazon. So kind of an important question. Let's look at what the question has to say. We are given a table called employees with 4 different columns: employee ID, event day, event time, and out time. Combined columns: employee ID, event day, and in time is the primary key of this table. The table shows the employees entries and exits in an office. Event day is the day at which this event happened. In time is the minute at which the employee entered the office, and out time is the minute at which they left the office. In time and out time are between 1 and 1440. It is guaranteed that no two events on the same day intersect in time, and in time is always less than out time. Okay. We are asked to write a solution to calculate the total time in minutes spent by each employee on each day at the office. Note that within one day, an employee can enter and leave more than once. The time spent in the office for a single entry is out time minus in time. Order of the result does not matter. Okay. So basically, if we need is for every particular day and employee ID, what is the total time spent in the office? So for example, on 28th of November 2020, employee ID 2 had two instances. First, in time was 4 and out time was 32. So 32 minus 4, that is 28 minutes. And then a second instance where in time is 55 minutes and out time is 200. So 145 minutes spent. So total time spent on 28th of November 2020 by employee ID 1 is 28 plus 145, that is 173. And similarly for all others. And that is how you have in your output. So basically this is not a very difficult question. All we have to do was we need to group by the event day, because for every particular day and employee ID, so group by the event day and the employee ID and find the difference and sum that up. So what we need to do is, from this table called employees, let's group by the event day and then by employee ID and then return the event day, and this should be aliased as day because that is what we need in our output. Then we also need the employee ID, and what we need is we need the difference between out time and in time. That is going to give you for every event how much time is spent in the office, and for every event day and employee ID we need to sum that up. So sum of out time minus in time. Okay, and this should be aliased as total time. Okay, so now since we do not need to order this by anything, let me go ahead and run this. Let's see what do we get in our output. Yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it so we pass all the test cases. So yeah, this is accepted and this is how we do it. So not a very difficult question. All we had to do was for every particular event day and the employee ID. So we grouped by that, and then we needed to find out the total time spent in the office. And the question says that time spent in the office in a single entry is out time minus in time. Since we are grouping by, if once you have the total times in each of the entries for a particular employee ID on a particular day, you just simply sum that up and you get the total time. So this is the 17th video of this series called Immediate Food Delivery Part 1. And if I look at the companies this question has been asked, so DoorDash a couple of times. Kind of an important question. Let's look at what the question has to say. We are given a table called delivery with 4 different columns: delivery ID, customer ID, order date, and customer preferred delivery date. Delivery ID is the primary key, that is column with unique values of this table. This table holds the information about the food delivery to the customers that make orders at some date and specify a preferred delivery date on the same order date or after it. If the customer's preferred delivery date is the same as order date, then the order is called immediate, otherwise it is called scheduled. We are asked to write a solution to find the percentage of immediate orders in the table rounded to 2 decimal places. Okay, so let's look at, so here we have about 6 records, right, of various delivery IDs, the customer who ordered it, their order date, and their preferred delivery date. So we need the percentage of immediate, that is order date is equal to the customer preferred delivery date. So how many of such rows we have that satisfy that? 1, 2, and that's it. So 2 out of 6, that is 1 divided by 3, that is 33.33% are the immediate percentage orders. So what we need to do in this case is we can try to count the total number of immediate delivery orders and then divide by the total number of records in this delivery table, and that is going to give you the percentage of immediate orders, right? So what we can do is from this table called delivery, what we need to do is firstly we need to find out, so to calculate the percentage in the numerator you need the number of immediate delivery orders. So return, we need the number of immediate delivery, and we have learned previously in this series as well as in the SQL 50 series that how you can use the sum function to basically count things. So what if I check for a condition that if your order date is equal to customer preferred delivery date, then you assign the value 1, else you assign the value 0, and if you sum that up, so what will these rows will assigned? So this one will be assigned 0, 1, 1 and 0, 0, 0. So if you sum the entire thing, it is going to be 0 plus 1 plus 1 plus 0, 0, 0. That is going to be 2. And 2 is the number of immediate delivery orders, right? So you see how we can use the sum function to count basically. So that is what we are going to do. So check for the condition that if order date is equal to customer preferred delivery date, let me just copy this so that is easier. Okay, customer preferred delivery date, then basically this is an immediate order, so assign the value 1, else you assign the value 0 because everything else is a scheduled delivery. And once you have the ones and zeros assigned, you simply sum this up, so that is going to give you the count of total immediate orders. Okay, and once we have this, then we need to find out the percentage. We simply need to divide this by the total number of orders. And how to get that? Basically count star, that is total number of records in this table, and we also need to round this to 2 decimal places. But first we need to convert this into a percentage, so multiply it by 100 and then round this entire thing to decimal places and alias this as immediate percentage. So if I just go ahead and copy and paste it here, so immediate percentage. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it so we pass all the test cases. So this is accepted and this is how to do it. Not a very difficult question. All we had to do was firstly identify the number of immediate orders, and the way we did was use the sum function to perform a count of immediate orders by checking for a condition and assigning values such as ones and zeros. And then once we had the immediate orders, then we divided by the total number of orders, that gave the percentage of immediate orders, and we rounded to 2 decimal places. So this is the 18th video of the series called apples and oranges. If I look at the company this question has been asked this, so Facebook or Meta, let's look at what the question has to say. We are given a table called sales with 3 different columns: sale date, fruit and sold number. The combined column sale date and fruit is the primary key, that is combination of columns with unique values of this table. This table contains the sales of apples and oranges sold each day. We are asked to write a solution to report the difference between the number of apples and oranges sold each day. Return the result table ordered by sale date. Okay, let's go through this example. So here we have various records for different sale dates and the fruit, apple and oranges and the quantity of them being sold. Then obviously for 1st of May 2020, what is the difference? 10 minus 8 between apples and oranges, that is 2. For 2nd of May 2020, 15 minus 15, 0 and so on. So that is what we have in our output. So to solve this question, what we need is we need to group by the sale date, because for every sale date we need the difference, and then we can employ the if function or the case when function, whatever suits you best, to say that okay, for a particular day, 1st of May 2020, if your fruit is equal to apples, return the sold number, else you return 0 and sum that entire thing. That is going to give you for every particular day how many apples were sold. Similarly, you can do the same for oranges and you can get that. So let's try to make that by demonstrating step by step. So from this table called sales, if I group by the sale date and return the sale date, so return sale date, and let me try to get the number of apples and oranges as 2 different columns. So what I'm saying is if your fruit is equal to apples, then you return the sold number, else you return the 0. So for example, in this particular group, right? So first of May 20, you have apples and oranges. So we are just counting the number of apples for the first column. So whenever your fruit is equal to apples, then you return this, else you return 0, and then you sum this up. So that is going to give you the total number of apples. So if I go ahead and sum this entire thing, and let me alias this as, let me do apples. Okay, let me go ahead and run this, right? So let me do this and then let's see what do we have. So here for every particular day, we have how many apples were sold. So 10, 15, 20 and 15. Exact same thing can be done for oranges as well. So if I go ahead and copy this here and paste it and change it to oranges. So if your fruit is equal to oranges, then you return the sold number, else you return 0 and alias this as orange. So if I go ahead and run this now, then let's see what do we get in our output. So here you have apples and oranges, and you need to calculate the difference between the two. So instead of creating a third column, what you can basically do is, this entire thing is giving you the number of apples on every particular day. This entire thing is giving you the number of oranges on every particular day. So you can simply put a different sign here. So if I just go ahead and do minus, and let me bring this down here so that it's easier for us to view. And this entire, so obviously this is apples, this is oranges. So the difference is whatever is required in our output, and this should be aliased as diff. So let's rename as diff, and it should also be ordered by sale date. So order by sale date in ascending order. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how to do it. Not a very difficult question. All we had to do was, for every particular sale date, we found out, okay, what is the total number of apples sold, what is the total number of oranges sold, and simply differentiated the two. So, and again, this is exactly like what we did in the previous video and earlier in the SQL 50 and Advanced SQL 50 series as well, that we can use the sum function to perform a count. That is what we did here. So but this is the 19th video of the series called number of calls between two persons. If I look at the companies this question has been asked in, so Facebook and Amazon, quite a number of times. So let's look at what the question has to say. We are given a table called calls with three different columns: from ID, to ID, and duration. This table does not have a primary key, that is column with unique values, and it may contain duplicates. This table contains the duration of a phone call between from ID and to ID, and then are not same. We are asked to write a solution to report the number of calls and the total call duration between each pair of distinct persons, that is person 1 and person 2, where person 1 is less than person 2. Order of the result does not matter. Okay, let's go through this example. So here we have various people who place the call, so from and to the person who they called, and the duration of the call. So obviously if we look at various combinations, so from 1 to 2 or from 2 to 1, obviously the two people that are talking are 1 and 2, right? So both of these should be considered as one distinct pair. And what is the total duration of 1 and 2 is 59 plus 11, that is 70. Similarly for 1, 3, there is only one of these rows, so 20. For 3, 4, we have 1, 2, 3, and this one is also 3, 4, right? So you sum all these things up, and that is what we have in our output. Okay, so the first thing that we need to do is, in this case, is we can create, so in our output we need the person 1 and person 2. So basically we can use, you take the columns from ID and to ID, whichever is smaller, that is called person 1, because it says, right, person 1 is always less than person 2. So, and similarly you take the from ID and to ID, and the greater one is going to be person 2. So what we can do is we can create those columns so that we have the distinct pairs arranged in the manner that we want. So what I'm saying is, from this table called calls, what we can do is we can have, okay, return. Now you might be thinking, okay, let's take from ID and to ID and perform the minimum. No, but remember, minimum works like this, right? So downwards. Minimum of from ID and to ID, it won't work. Minimum of from ID, it will work. So we need to get another function that actually calculates row wise minimum or maximums, and that is called the least function. So least of from ID and to ID, so whichever is least is person 1, right? So as person 1. Similarly, we need to get the greatest of these two is going to be the person 2. So if I go ahead and do greatest of from ID and to ID is person 2, and then we need to get the duration part. So third column is duration. Let me go ahead and run this and let's see whether we are getting the person 1 and person 2 as is required by us. Okay, so if I look at our output, so now if you look at these, right, so this is what we had: 1 259, 1 259, and then we had 2 and 1. But since we are saying that least one is, so least out of these two is 1, so that is person 1 and this is person 2, and the duration is 11, right? Similarly for everything else. Now once we have this, what we can do is we can group by person 1 and person 2 and sum the duration column, and that is going to give you the total duration, and you can simply count star to get the number of call counts. So what I'm saying is this is going to give you this, right, from this, and then what we can do is group by, right, group by person 1 and person 2, but this entire thing is basically person 1, this entire thing is basically person 2. Person 1, that is the least of from ID and to ID, and then person 2, which is basically the greatest of these two. So copy this here, paste it here, and then what you need to do is, let me just bring it down here. Okay, so group by these two, so return this as person 1 person 2, and we need the call count. Call count is basically going to be count star. So count of star is going to be call count. Let me just bring it down here so that it's easier for us to write. So as call count, and then what we need is we also need the duration, that is total duration. So we basically sum the duration column, and that is going to give you the total duration as total duration. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. Our output is same as expected output, right? Let me go ahead and let me just drag it left. Okay, and let me go ahead and submit it to see if it passes all the test cases. So this is accepted, and this is how to do it. So not a very difficult question, but what we had to do was, firstly we need to rearrange these from IDs and to IDs in the manner that we want, so that we can identify the distinct groups and do not classify 1 and 2 as different from 2 and 1, because two same people are talking. It's just that who is calling and who is getting the call. Once we identified those groups, then we simply counted the number of calls and sum the duration to get the total duration. So this is the 20th video of the series called Bank Account Summary Part 2. And if I look at the companies this question has been asked, is that Uber, kind of an important question. Let's look at what the question has to say. We are given a table called users with two different columns, account and name. Account is the primary key, that is column with unique values for this table. Each row of this table contains the account number of each user in the bank. There will be no two users having the same name in the table. We are also given a second table called transactions with four different columns: transaction ID, account, amount, and transaction on. Transaction ID is the primary key, that is column with unique values for this table. Each row of this table contains all changes made to all accounts. Amount is positive if the user received money and negative if they transferred money. All accounts start with a balance of 0. We are asked to write a solution to report the name and balance of users with a balance higher than 10,000. The balance of an account is equal to the sum of the amounts of all the transactions involving that amount. Order of the result does not matter. So here are few records in the users and the transactions table. So if we look at it, right, so for example, account ID 900,001. So here we have three different transactions. So 7,000 plus 7,000 minus 3,000, right? So it is going to be 11,000, and 900,001 belongs to Alice. So Alice should be in the output. Similarly for 900,002, it is only one amount and it is not greater than 10,000. So it should not be in our output. For 900,003, 6,000 plus 6,000 is 12, plus minus 4 is 8, which is less than 10,000. So this should also be not be in the output. So the only person that should be in the output is Alice, and the total balance is 11,000. And that is what we have. We have already learned in this series earlier, as well as in the sequel 50, that whenever such kind of questions arise where you need one column from table 1 and another column name from table 2, the first thing that we should do is we should try to join these. And then what we can do is we can group by the account and the name and calculate the sum, right? So what we can do is, from this table called transaction, let's alias this as T. Let us left join. You can also do the inner join. I am preferring to do the left join part. Left join users U on T dot account is equal to U dot account. Okay, another thing I just wanted to share here is that instead of writing these things, right, so on t dot account, u dot account, if the name of the column is same in both the tables, you can shorten this thing up to write using, right, using and within parentheses the name of the column that we're trying to join on. But remember one caveat, that the name of the column should be same in both the tables, then only this will work, otherwise it won't. Okay, so using this thing, let's keep all the columns from the transaction table. So select t dot star, and then we are only concerned about the names because we need names in our output. So u dot name. Okay, let me go ahead and run this. Let's see what do we get in our output. Let me drag it to the left so that it is easier for us to view. And if I look at our output, so here for every transactions we also have the name of the person who holds this account. Then what we can do is we can group by the account first and then name. Remember, even though this question says there will be no two users having the same name in the table, so you can directly go ahead and group by name. But in general sense, just you think about it, in real world it is highly possible that two people can have same name, and obviously their account numbers will be different, right? So it is always a good practice to group by something unique first. So group by the account number, right? So account is coming from the transactions table, so t dot account and then t dot name. So that is going to give you, okay, account and name. In our output we only need the name of the person, so we need the name. So we need, okay, in our output return the name, and then if you sum this amount column for every account, that is going to give you the balance. So if we go ahead and do sum of amount is coming from the transactions table, so t dot amount, and let's alias this as balance. Okay, this is not yet complete, but let me go ahead and run this. Let's see. Okay, so if we look at our output, we have for every person, Alice, Bob and Charlie, what is the total balance at the end. But the question asks us to have only those names and balance of users where the balance is higher than 10,000. That is, we need to filter based on an aggregate. We need to filter based on sum of the total amount, that is balance, should be greater than 10,000. You remember what we need to use in this case? Having. So having the sum of t dot amount, so t dot amount is greater than 10,000. We are only required to keep those rows. Now if I go ahead and run this, let's see what do we get. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. Not a very difficult question, but what we need to do is, firstly, since we need the name of the person in the output, so we join the transactions table with the user so that we can get the name. And then we first time use the using clause instead of on. It is basically doing the same thing, but we need to make sure that the name of the column that we are joining in from both the tables is exactly the same. And then we grouped by the account and name and returned the name and got the total balance by summing the amount column. And then we only kept those rows where the total balance is greater than 10,000. So this is the 21st video of this series called duplicate emails. And if I look at the companies, this question has been asked in, so Amazon and Uber, a quite number of times. So kind of an important question. Let's look at what the question has to say. We are given a table called person with two different columns, ID and email. ID is the primary key, that is column with unique values for this table. Each row of this table contains an email. The email will not contain uppercase letters. We are asked to write a solution to report all the duplicate emails. Note that it's guaranteed that the email field is not null. Order of the result does not matter. Okay, let's go through this example. So here we have three different records, and a@b.com is a repeated email. So obviously that should be in our output. So to solve this question, what we need to do is, even though this question says that the email will be in lowercase, it is better to write our query in a generalized manner and try to use the lowercase before grouping. And then the logic to do this is, you can group by the email and count the number of IDs, and since ID is a unique value, right? If you have the count of ID more than one, then obviously that email has been repeated more than once. So we can use the having clause to filter based on an aggregate. So what I'm saying is, from this table called person, let's group by the email column, you can directly go ahead and group by, but what I like to do is I always like to generalize my query. So I always make sure that, okay, let's do this lower. So even if in some of the test cases the email has a uppercase in some of the letters, it will convert everything to lowercase and try to find out whether the email is actually repeated or not. So group by the lower. Then what we need to do is we need to count the number of IDs. That is going to give you how many times this particular email is present in this table. So having only count of ID, we do not need to write distinct because here it also already says that ID is a primary key, that is unique values, right? So having count of ID greater than 1, because that means this email has been repeated more than once in the table, and those are the emails that we need to report, right? So having count of ID greater than 1, those emails we need to return. So return that email, or what we can do is we can just copy this here, lower part of the email. You can directly write email, but I'm just trying to generalize my query so that it works and passes every test cases, even the ones that are not present here and are going to be included in the future. Okay, and since we do not need to order this by anything and no alias is required as well, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how to do it. Not a very difficult question. All we had to do was group by the lowercase email in case you want to generalize your query, and then count the number of IDs. So that is going to give you the number of times this email has been repeated. And if your count is greater than 1, that means it is a duplicate email. So we return those emails. So this is the 22nd video of the series called Actors and Directors Who Cooperated at least 3 times. And if I look at the companies this question has been asked is to Amazon for a couple of times. Let's look at what the question has to say. We are given a table called actor director with 3 different columns: actor, director ID, and timestamp. Timestamp is the primary key, that is column with unique values for this table. We are asked to write a solution to find all the pairs of actor and director where the actor has cooperated with the director at least 3 times. Order of the result does not matter. Okay, let's go through this example. So here we have a number of records for actor, director, and the timestamp. So which actor director combination is at least 3 times? So 1 and 1 has timestamp 0, 1 and 2, right? So at least 3 times this actor director combination 1 and 1 has cooperated with each other. But if we look at 1 and 2, so only 2 times, 2 and 1 only 2 times. So here 1 and 2 and 2 and 1 are not the same thing. Why? Because actor ID 1 is not going to be the same as director ID 1. That is what we have in our output. So not a very difficult question. What we need to do is basically we can group by the actor ID and then the director ID, and since we are filtering based on an aggregate value, that is the count of the combination, then we can use the having clause. So what I'm saying is, from this table called actor director, right, if we can group by the actor ID and then director ID. Okay, and let me return the actor ID and director ID, and let's count how many times they have cooperated. Each pair has cooperated. So return this, and let me do count star, and let me go ahead and run this. Let's see what do we get in our output. Not yet complete, but let's look at what we have. Okay, so here we know that actor ID 1 and director ID 1 has cooperated 3 times. 1, 2 has cooperated 2 times, 2, 1 has cooperated 2 times. We are only required to keep actors and directors who have cooperated at least 3 times. That is, the count star should be at least 3 or more. So what we can do is we can do count star having count star greater than equal to 3, and in those cases we need to keep only the actor ID and director ID. So let me remove this part. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. Not a very difficult question. All we had to do was group by the actor ID and director ID so that we have the pairs, and then we filtered by an aggregate value, that is at least they cooperated 3 or more times. So we use the having clause and we return the actor ID and director ID. So this is the 23rd video of the series called customer order frequency, and if I look at the companies this question has been asked in, so Amazon on, let's look at what the question has to say. We are given a table called customers with three different columns: customer ID, name, and country. Customer ID is the column with unique values for this table. This table contains information about the customers in the company. We are also given a second table called product, again three different columns: product ID, description, and price. Product ID is the column with unique values for this table. This table contains information on the products in the company, and price is the product cost. We are also given a third table called orders with five different columns: order ID, customer ID, product ID, order date, and quantity. Order ID is the column with unique values. This table contains information on customer orders. Customer ID is the ID of the customer who bought quantity products with ID, product ID. Order date is in the format year, month, date when the order was shipped. We are asked to write a solution to report the customer ID and customer name of customers who have spent at least $100 in each of June and July of 2020. The order of the result does not matter. Okay, let's go through this example. So here we have three different customers, four different products, and a number of orders. Let me just drag it to the right. Okay, and what we need is who is a customer who has spent at least $100 in June as well as July of 2020. Just by looking at it, right? So if we look at for customer ID 1, right? So customer ID 1 has bought a product ID 10 in June of 2020. The quantity is 1 and product ID 10 has a price of 300. So obviously in June, this person has spent $300. In July, there are two products: product ID 20 whose value is 10 multiplied by 1 is 10, and then product ID 30 whose value is 45 and quantity 2. So 45 into 2 is 90 plus 10 is 100. So customer ID 1 has at least spent $100 in both June and July of 2020 and therefore should be in the output. Similarly, we can go ahead and calculate for customer ID 2 and 3, and that is what we have in our output. So here, since we need the customer ID and name in the output, so obviously since the information is in different tables, so the first thing that we should do is we should perform a join of orders table with the customers table to get the name of the customer. But we just saw that we also need the price to calculate the total spend. So basically what we need to do is we need to join these three tables together so that we have the relevant columns. So price from the product table and name from the customers table, so that we can go ahead in our calculations. So what I'm saying is, if I go ahead and start writing this, so from this table called orders, because we are concerned about the orders and the spend, right? So from this table called orders, if I alias this as O, let me go ahead and left join the customers table aliased as C customer ID is equal to C dot customer ID, and then again go ahead and left join the product table. So product aliased as P on O dot product ID is equal to P dot product ID. Okay, so once I perform this join, we are only required to keep certain columns, right? So what I'm doing is, let's say we keep all the columns from the orders table, so O dot star, and I'm only interested in the price column from the product and name column from the customers table. So C dot name from the customers table and P dot price column. Okay, let me go ahead and run this. Let's see what do we get in our output. Let me just drag it to the left and to above so that this is what we have. Okay, so basically this is what we have: order. So first five columns coming from the orders table, then we have the name of the customers as well and the price. This column price as well as the quantity is going to help us calculate the spend. Name and customer ID is what we need in our output. Okay, so once we have this, then we are only concerned about June and July of 2020. Okay, let me switch to Excel so that I can display the entire flow, which is easier to understand. So these are the three tables that we have, right? Customers table, product table, and orders table, and we just performed the join and we have this now. So you have the five columns from orders, and then we got the price column from the product and the name column from the customers. Now we are only concerned about June and July of 2020. So obviously we can see there is only one row which is not in June or July of 2020. So what we can do is we can use a where clause. So where your year can be 2020 and month is in 6 or 7. So what I'm doing is, from this right, we are doing that we are only concerned about those rows where year of the order date, right? So year of the order date on order date is coming from the orders table. So O dot order date is equal to 2020 and month of the order date. So O dot order date is in, so it should be June or July. So is in 6 or 7. Remember, we have learnt about this month function that it will extract the value of month from 1 to 12. Okay, now let me go ahead and run this. Let's see what do we get in our output. Let me just drag it above. So here now we have all the rows except the last one, right? So similarly here we can go and see that this one is not present. Okay, now once we have this, then we are only concentrated about the June and July of 2020. Then what we can go ahead and do is, for every customer ID and name, we can calculate the in the month of June as well as in the month of July, what is the total spend. That is, we can go ahead and do group by, right? So if I go ahead and do group by the customer ID, because customer ID is the unique thing, right? Names can be same, but customer ID is a unique value. We should firstly group by customer ID, and also we need that in our outputs. Customer ID, this column customer ID is from the orders table, right? It is not from the customers table. Remember here, if we look at our orders table, we have the customer ID, right? Okay, let me just drag it to the left. Okay, so group by O dot customer ID, and then name is coming from the customers table. Let me just drag it again. Okay, O dot customer ID, and then C dot name, and then also the month part, right? So month of O dot order date, and let me return these three columns in my output. So copy this here, paste it here, return these three columns, and then we calculate the sum of the quantity multiplied by price, because that is going to give you the spend. So sum of quantity is coming from the orders table. So O dot quantity, multiply it by price is coming from the product table. So P dot price, and that is going to, and let us alias this as spend. Okay, let me go ahead and run this. Let's see what do we get in our output. Let me just drag it to the right because we do not need this much space. And okay, let me see. Okay, so here we have customer ID, name of the customer, and in the months of June and July, what were their total spend. So let me switch back to Excel. So now once we grouped by, we ignored this one, right? Because we are considering only 6 and 7 months. So now this is what we have. Okay, now we are only concerned about $100 or more spend. So what we can do is, we can even do filtering based on an aggregate. So we just calculated this spend quantity, right? Spend is sum of O dot quantity multiplied by P dot price. So we can filter this and say that rows like these, right? So for example, this one, this is, we do not care, because anyway the question is asking $100 or more spend. So how can we achieve that? We have learned that if we want to filter based on a aggregate value, we can simply go ahead and do having, right? So having, this is the aggregate that we calculated, sum of O dot quantity multiplied by P dot price. So here we can say that, okay, having this is greater than equal to 100. Let me go ahead and run this, and instead of having this, let me just alias this as month so that it's easier, and let me bring this down so that it's easier for us to read. Let me go ahead and run this. Let's see what do we get in our output. So now what we have is all the customers and their name, and in the month of June or July, the spend was $100 or more. Now just by looking at it, we can see that even though Jonathan and Mustafa had at least $100 spent in month of June, but they do not have any spend in July. So obviously the only person who is spending at least $100 both in June and July is customer ID 1, whose name is Winston. So this entire thing, right? So here if I go back to Excel, so this entire thing can be treated as a table, and what we can do is, from this we can go ahead and do again group by the customer ID and the name, and then keep only those rows where the number of rows is equal to 2, because number of rows is equal to 2 means that the month 6 as well as 7 is present in the output. And since we already have taken care that the spend is at least going to be $100, that is going to give you all the customers and their name who have at least $100 spent in as both June as well as July. So what I'm saying is, this entire thing becomes our table, right? So entire thing becomes our table and goes into parentheses, and let me alias this as table T. And what I'm doing is from this table T, let me group by, right? So group by the customer ID, and it should be T dot customer ID and T dot name, and then return that, right? So return both of these columns. So return T dot customer ID and T dot name, because these are the columns we need in our output. If we look at this, our output, so ID and name, and we need to keep only those rows having the count of number of rows equal to 2, right? Why we are doing this? Because just look at for Jonathan, right? So this is what we have ignored already. So for Jonathan, this is the only row that we have. So count of Jonathan is, number of rows is 1, count of Mustafa is again 1. Obviously we do not need these kind of customers in our output. So if I go ahead and run this now, let me just, yeah, so this is the entire solution. Let me go ahead and run this. Let's see what do we get in our output. Let me just drag it above. So now this is accepted. Our output is same as expected output. Let me go ahead and submit it so we pass all the test cases. So yeah, this is accepted, and this is how we do it. So yeah, even though this says easy, but actually it is kind of a lengthy question. And just to reiterate, what we basically did was we joined this on product ID column and the customer ID column, and then we have the relevant columns. And then what we did was we are only concerned about June and July of 2020, so we ignored all the rows which are not of June and July. And then what we did was grouped by the customer ID as well as the name, and multiplied quantity with price to get the spend for a particular month, June or July. And once we had that, then we are only concerned about the spends greater than or equal to $100. And then what we did was we treated this entire thing as a table, and then we grouped by customer ID and name, and had only those customers who have 2 rows in the table. So this is the 24th video of this series called Daily Leads and Partners. And if we look at what the question has to say, we are given a table called daily sales with 4 different columns: date ID, make name, lead ID, and partner ID. There is no primary key, that is column with unique values for this table, so it may contain duplicates. This table contains the date and the name of the product sold, and the IDs of the lead and the partner it was sold to. The name consists of only lowercase English letters. We are asked for each date ID and make name, find the number of distinct lead IDs and distinct partner IDs. Order of the result does not matter. Okay, so here we have various dates, right, and various records, make name, lead ID, and partner ID. So for example, 8th of December 2020 and Toyota, how many distinct lead IDs are there? So there are 0 and 1. So 2 distinct lead IDs, and similarly, how many distinct partner IDs? So 1, 0, and 2. So 3. So for 8th of December 2020 and Toyota, 2 distinct lead IDs and 3 distinct partner IDs. And similarly, we can go ahead and do for all other date IDs and make name. So here we have for 8th of December 2020, Toyota, 2 unique leads and 3 unique partners. Okay, so what we need to do is we can go ahead and group by the date ID and the make name, and then count the number of distinct lead IDs and alias this as unique leads, and then count the number of distinct partner IDs and unique partners. Now, if you want to make your solution even more generalized, even though this question says that make name is going to have only lowercase English letters, what you can do is you can make sure that it is always lowercase by using group by lower of make name, right? So what we can do is we can do from this table called daily sales, we can go ahead and group by the date ID, and then yes, you can go ahead and directly do make name because the question already says that everything is going to be in the lowercase. But I just like to generalize so that if in the future there is a test case added, make names not always being in the lowercase. And in the real world also, right, you just think about it, there is going to be data anomalies, so better to incorporate that in your code beforehand. So lower of make name, and then what we can do is we can return these two things. So copy this here, return the date ID and the make name, and let's alias this as make name, because in our output we need that as make name. And then what we need to do is we need to count the distinct lead IDs, right? So count the distinct lead ID and alias this as unique leads. And then we also need to count the distinct partner ID and alias this as unique partners. Okay, I think this looks good. Since we do not need to order this by anything, let me go ahead and run this so that it's see what we can get in our output. So yeah, this is accepted. Our output, if we like just drag it to the left, our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted and this is how to do it. Not a very difficult question. All we had to do was group by the date ID and the make name, and I included a lowercase just in case in future there are test cases that try to test that. And then we counted distinct number of lead IDs and alias this as unique leads, and counted the distinct number of partner IDs and have that as unique partners. So this is the 25th video of the series called Friendly Movies streamed last month. And if I look at the companies this question has been asked in, so Amazon, let's look at what the question has to say. We are given a table called TV program with three different columns: program date, content ID, and channel. The combined columns program date and content ID is the primary key, that is combination of columns with unique values for this table. This table contains information of the programs on the TV. Content ID is the ID of the program in some channel on the TV. We are also given a second table called content with four different columns: content ID, title, kids content, and content type. Content ID is the primary key, that is column with unique values for this table. Kids content is an enum category, that is it can take the y's and no's, that is yes or no, where y means a content is for kids, otherwise n is not content for kids. Content type is the category of the content as movies, series, etc. We are asked to write a solution to report the distinct titles of the kid-friendly movies streamed in June of 2020. Order of the result does not matter. Okay, so let's go through this example. So here we have different records for TV program table as well as content table. So obviously in June of 2020, so there are two things that have been streamed: content ID 1 and content ID 4. Now content ID 1 is Leetcode movie, which is not kid friendly, but content ID 4 is Aladdin, which is kids friendly, and it is also a movie. So in the output we need to have Aladdin as our output. Okay, so to do this, since we need to filter by the kids content as well as the content time, and also the program date should be June of 2020. So since all these columns are in two different tables, the first thing that we should do is we should merge this information into one. So we are concerned about what were streamed, right? So we need to join the TV program with the content. So from this table called TV program aliased as T, we can either go ahead and do inner join or we can do left join. You can do whatever you prefer. I usually prefer left join. So left join the content table aliased as C on T dot content ID is equal to C dot content ID, and let's keep only those columns which we require. So here only the program date from the TV program makes sense, right? And then in the content table we can keep all the columns, even though we do not require content ID, but like we can keep it. So what I'm saying is return the program date column from TB program, so program date, and then let's keep everything from the content table. Okay, now let me go ahead and run this. Let's see what do we get in our output. Let me just drag it above. So here we have program date, content ID, title, kids content, and content type. Now we need to have three filters. Firstly, the program date should be in June of 2020. Secondly, the kids content should be yes. And then thirdly, a content type should be a movie. So what we can do is we can perform all the three here. So where we are only concerned about the year and month of program date. So either you can do year is equal to 2020 and month is equal to 6, or you can directly go ahead and format this table, right? So date format the column program date, which comes from the TV program. So T dot program date, and it should be, we are only concerned about year and month. So capital Y for year and small m for month. It should be equal to basically 2020 06, right? So June of 2020. So first one is done. Then we also need to make sure that kids content is coming from C dot kids content is equal to yes, and also it should be a movie. So and C dot content type is equal to movies. So okay, now let me go ahead and let me just drag it down. So this is the entire code that it look like. Now let me go ahead and run this. Let's see what do we get. Okay, so if we look at our output now, so there is only one movie that satisfy all these three things. So in this, we only need to return the title, right? That is what we have in our output, thus the title. So what we can do is, and that should be distinct titles, right? So remember, this Aladdin can also be streamed multiple times in June of 2020. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit to pass all the test cases. This is accepted and this is how to do it. Not a very difficult question. All we had to do was firstly, we need to merge the information in both the TV program as well as the content table, because we need to filter by two columns in the content table and the third column in the TV program table. And once we had the information, we filtered by whatever was required, and then we only returned the titles from the content table. So this is the 26th video of the series called Countries You Can Safely Invest In, and let's look at what the question has to say. We are given a table called person with three different columns: ID, name and phone number. ID is the column of unique values for this table. Each row of this table contains the name of a person and their phone number. Phone number will be in the form 3x's and dash 7y's. Both can contain leading zeros. We are also given a second table called country with two different columns, name and country code. Country code is the column of unique values for this table. Each row of this table contains the country name and its code. Country code will be in the form of 3x's, where x is digits. We are also given a third table called calls with three different columns: caller ID, callee ID and duration. This table may contain duplicate rows. Each row of this table contains the caller ID, callee ID and the duration of call in minutes. Caller ID is not equal to callee ID. Okay. A telecommunications company wants to invest in new countries. The company intends to invest in countries where the average call duration of the calls in this country is strictly greater than the global average call duration. We are asked to write a solution to find the countries where this company can invest in. Order of the result does not matter. Okay, so here we have various records in the person, country as well as the calls table, and then what we need to basically find is, so how will you calculate the global average? You can simply go ahead and calculate from this table called calls, calculate the average of the duration. That is going to give you the global average duration. Then we also need to find out for every country what is the average call duration, and only keep those countries where the average call duration of the country is greater than the overall average of the globe. So apparently if you do that, you get the country Peru. Okay, let's try to check whether this is correct or not. Okay, since you already know that here we need to perform a join, because here we also need to check the name of the country, then we also need to employ the durations, etc, right? So obviously we need to perform a join, but this is where you can play smart and try to find out, okay, yes, we know we need to perform a join, but how? That is going to decide how efficient our solution is. So for example, here if you start with the calls table and try to find out, okay, in the calls table I am going to append for every caller ID and callee ID their phone numbers, and then from there I am going to find out the country code. The problem would be that here you need to join the calls table twice on the person table to actually get the phone number. Firstly, you will make sure that, okay, where your caller ID is equal to ID, and then you get the phone number, and then you need to again join on callee ID and get the phone number. However, if you do this reverse, you only need one join. Here if you do from the person table try to join the calls table, then what you can do is you can simply say that, okay, whenever your ID is either caller ID or callee ID, because you cannot call itself, so either this person, so for every row, right? So for example, row ID equal to 3, Jonathan can either be the caller or the callee. So here for example, the person is a caller, again caller, here callee. So it will try to find, okay, this row it will append, this row append, this row it will append based on callee ID. Similarly, it will go other and try find out, okay, there is nothing, so okay, Jonathan is done. Then it moves to another person in the person table. We can go ahead and do from this table called person aliased as P, let us left join the calls table, right? Left join the calls table aliased as C on P dot ID. P dot ID is in, right? P dot ID is in, either you are a caller ID, so C dot caller ID, or it is a C dot callee ID. It is basically the same thing as writing on P dot ID is equal to C dot caller ID or P dot ID is equal to C dot callee ID. Okay, so let me keep all the columns for here. We do not require all the columns, but let me just keep it here for the sake of it. Let me go ahead and run this. Let's see what do we get in our output. Okay, let me drag it above and let's see how our output looks like right now. Let me just drag it to the left. So here we have, okay, so here we had the person's table, right? Person, and then this person, Jonathan, we saw the person is involved in 3 different calls, 2 of them as caller and 1 of them as callee. Okay, and similarly we have the duration of all those calls. Now we also need to make sure that we append the name of the countries based on the country code. So what we can do is we can write, okay, from this now again go ahead and perform a left join on the country table aliased as, let's say, CO, because we have already alias calls as C, and then on. So you take the first 3 letters of the person table because that is going to give you the country code, right? So on left of P dot phone number, you take the first 3, and that should be equal to the country code from country table. So CO dot country code. Okay, now let me go ahead and run this. Let's see what do we get in our output. So here, if I scroll up, let me just drag it to the left so that it's easier for us to view. So now you have that, okay, for Jonathan, this person is from Peru. Similarly, for Elvis, Peru, Morocco, etc. So now you have the countries assigned. Then what you can do is you can simply go ahead and group by the country name, because in the output we need the name of the country, right? So what I'm saying is, let me just drag it down so that we can, start writing the query. So this is the code that is until now, and then let me go ahead and write, okay, so now group by the name of the country. So name is coming from the country table. So CO dot name, and then you return the name of the country, but you should also make sure that the average duration of the country is greater than the global average. So you can calculate the average of duration, and that should be greater than the global average. So that means you need to filter based on an aggregate value. So here, to filter based on an aggregate value, we always use having. So having the average of the duration column comes from calls table. So C dot duration, it should be greater than the global average. So what you can do is return average of the duration column directly from the calls table. Now let me go ahead and run this. Let's see what do we get in our output. Okay, so now here if we look at it, our output is name and Peru, and here we need basically to alias this as a country. So we can just, let me just drag it to the right because we do not need this much space now. Okay, as country, and now let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. Let me just drag it above, and if I look at our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. Okay, so yes, kind of medium difficulty, because the first thing that we had to identify which table to keep on the left and the right, even though you can flip it up, but then you are going to have at least one more join in your solution. And secondly, what we did was, okay, we joined the person's table with the calls table on either your person is a caller or a callee, because you cannot be both. And then we got the name of the country as well. And then what we did was we grouped by the name of the country and made sure that it follows the question's logic that, okay, the average duration of the country is greater than the global average. So this is a 27th video of the series called Consecutive Available Seats. And if I look at the companies this question has been asked in Amazon a number of times, so kind of an important question. Let's look at what the question has to say. We are given a table called cinema with 2 different columns, seat ID and free. Seat ID is an auto increment column for this table. Each row of this table indicates whether the ith seat is free or not. 1 means free while 0 means occupied. We are asked to find all the consecutive available seats in the cinema. Return the result table ordered by seat ID in ascending order. Okay, the test cases are generated so that more than 2 seats are consecutively available. Okay, let's go through this example. So here we have 5 different records for 5 different seats and whether they are free or not. So what all seats are consecutively free? 3, 4 and 5, because 1 means free. So 3, 4 and 5 are consecutively free, and that is what we have in our output. So to do this question, the logic we need to employ is we can find that for every seat, whether the seat before that is free or not, or whether the seat after that is free or not. Because if a seat has to be consecutively free, so either the seat before that is free and the current seat is free, or the current seat is free and the next seat is free. So for example here, since there is no seat before this, so for this seat we need to look at, okay, what is the next seat? Seat ID 2, and it is not free. So obviously 1 and 2 are not consecutively free. Now let's look at 2 and 3. So this current seat is not free and the next one is free. So obviously not consecutively free. Now current seat is free. The seat before is not free, but the seat after is free. So 3 is going to be out in the output. Similarly for 4, the seats before as well as after is free. And for 5, there is no seat after 5, but the seat before 5, that is 4, is free. So 3, 4 and 5 are free. So to employ this logic, what we can do is we have learned about the window functions lead and lag. So we can try to find out whether the seat before the current seat and seat after the current seat is free or not. So how can we do that? From this table called cinema, let's keep both the columns, select star, and then try to find out where the status of the seat before the current row. So lag of the column free over, and you need to order by seat ID, and let's call this as before. Okay, and then similarly what we can do is we can find the status of the seat next to the current seat. So let me just copy this here, because all we need to do is just change this to lead, and then this should be aliased as after. Okay, now let me go ahead and run this. Let's see what do we get in our output. Okay, so if I look at my output, so obviously the current seat, there is nothing before this, so null, but after this the seat is not free. Similarly for seat ID 2, before this is free and after this is free as well. Okay, so now once we have this, since we came up with the logic that for a current seat to be consecutively free, the seat before that should be free or the seat after that should be free. So from this entire thing, let's call this entire thing that we created as a table T. So from this table called T, right? So this entire thing goes into parentheses, and let's call this as T. And then we need to keep only those rows where, so the current seat that is free is equal to 1, right? So the current seat is free and the before seat is free, right? So and before seat is equal to 1. Or if that is not true, then the current seat is free and the after seat is free as well. Okay, so what is this basically doing? So for example, here it will look at, okay, where free is equal to 1. Okay, so the current seat is free, but is the before seat free? No. Is the after seat free? No. So obviously 1 should not be in the output. Similarly for 2. But for this, right? So for seat ID 3, the before seat is not free, but after seat is free. Okay, so keep seat ID 3. Similarly for 4, and in the output, we only need the seat ID. So what we can do is, for these kind of rows, firstly, let me, keep all select star. Right? Let me just show you what this is going to return. Okay, so if I look at it, so it is going to return seat ID 3, 4 and 5. But we only require the seat ID. So return seat ID, and this should also be ordered by seat ID in ascending order. So order by seat ID. Okay, so this is how the entire solution looks like. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how to do it. Yes, not a very difficult question, but you need to know the window functions lead and lag if you want to apply this logic. Obviously, there would be other ways you can do this question as well. So what we did was, firstly, we found out the status of the seat before the current seat and after the current seat. And then we simply employed the logic that if a seat has to be consecutively free, so your current status should be free and before should be free. Or if this is not the true case, then current seed should be free and after seed should be free. Then you keep that particular seed that, okay, this is in a consecutive free seed. So this is a 28th video of this series called Rearrange Product Table. And if I look at the companies this question has been asked in, so Bloomberg, Amazon, Apple, a lot of times. Kind of an important question. Let's look at what the question has to say. We are given a table called products with 4 different columns, product ID and then store 1, 2 and 3. Product ID is the primary key, that is column with unique values for this table. Each row in this table indicates the product's price in 3 different stores, store 1, 2 and 3. If the product is not available in the store, the price will be null in that store's column. We are asked to write a solution to rearrange the products table so that each row has product ID, store and price. If a product is not available in the store, do not include a row with that product ID and store combination in the result table. Order of the result does not matter. So here what we need to do is, so here we have a couple of records for 2 different products, product ID 0 and 1, and 3 different stores and their prices in them. So what we need to do is row 1 should be product ID 0, store 1, price is 95. Then product ID 0, in store 2 the price is 100, product ID 0 and in store 3 price is 105. So you have 3 different rows. Now for product ID 1, store 1 the price is 70, and since product ID 1 is not present in store 2, so we do not need to include that in our output, and then product ID 1 and store 3. So in total you need to have 3 plus 2, 5 rows in our output, and that is what we have in our output. To solve this question, let's just forget about store 2 and store 3 for the moment, and let's see how we can get product ID and store 1 as records. So as like this, right? So product ID and then store and the value of the price. So if I go ahead and do from this table called products, I'm only interested in those rows where the value of store 1 is not null. Why? Because if the product is not available in the store, we do not have to include that row. So we make sure that, okay, where store 1 is, so value, this is storing the value of the price. So store 1 is not null, and what we need to return is return the product ID. Return the product ID. So you see output product ID. Then you need to return a column named store where you have the name of the previous column. So what you do is you return store 1 as column named store and then the value of the price. So this 95 is basically the value in the store 1 column. So store 1 as price. Okay, let me go ahead and run this so that let's see what do we get in our output. So here, if you look at it, right, so this is our output right now. So this entire thing is converted into product ID and store 1, their prices. Now, if we need to do the same thing for store 2 and store 3, what we can do is we can simply go ahead and copy this entire thing 2 more times, and then you will going to get the entire solution. So here you need to change that, okay, where your store 2 is not null, this becomes store 2 and store 2 values is the price. Similarly here you become store 3 price, and then where store 3 is not null. And since this question, so you remember this question is regarding advanced select and joins. So basically we are trying to join this information one over the another. How can we do that? We have learned that we can do this using the union function. So what we can do is we can simply go ahead and write, okay, whatever you get from this and this, you just union that on each other. So union. Okay, now let me go ahead and run this. Let's see what do we get in our output. Okay, so let me just drag it above. So here this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how to do it. Not a very difficult question, but what we had to do is firstly we need to do something for one column and then we need to repeat it for a couple of more times, and then we use the union function to join. So joining data is not just about left join, right join, inner joins, etc. It is also about concatenating things one over the another, and in that you can use union
So this is the 29th video of the series called sorted distance in a line, and let's look at what the question has to say. We are given a table called point with one column x. In SQL, X is the primary key column for this table. Each row of this table indicates the position of a point on the x-axis. We are asked to find the shortest distance between any 2 points from the point table. Okay, so let's look at the records that we have in this example. So here we have 3 different points, -1, 0 and 2. So obviously, what is the minimum distance between any 2 points in this? So distance between -1 and 0 is 1. Distance between -1 and 2 is 3. distance between 0 and 2 is 2. So the minimum distance is between -1 and 0, that is 1, and that is what we have in our output. So to solve this question, what we can do is we can perform a self join of this table on itself, or we can perform a cross join. We have learnt about cross join, that if you perform a cross join of this table on itself, it is going to give you all possible combinations. And if you do the same thing using a left join instead of doing this using a cross join, so what you can do is from this table called point aliased as p1, left join the table on itself and make sure that you are not considering the same point. So for example, the distance of -1 from -1 does not make any sense, right? Because the distance of point from itself is always going to be 0. So what I'm saying is, if we do this thing, right? So from this table called point aliased as p1, if I do a self join, and self join is can be done using left join, inner join, etc, right join, etc, right? So basically self join is a joining a table on itself as p2, and what we are doing is on p1 dot x is not equal to p2 dot x. Why am I doing this? So for example, just here imagine this, right? So here this is, let's say, p1 and this is p2. X is equal to -1. It will try and find -1 here, but if you find -1, so here you are going to have second column which is going to be -1 and -1, and if you calculate the distances between -1 and -1, it is going to be 0. Similarly for 0, similarly for 2. You do not need to get that, right? What you need to do is, when we do p1 dot x is not equal to p2 dot x, so for this row, it will say, okay, -1 is equal to x. So obviously this should not be in our output, but these two are not equal to x. So here it will populate two rows for this. So -1 0 and -1 2. Now for 0, it will say, okay, -1 is not equal and 2 is not equal. So for 0, it will have two rows and so on. So let me go ahead and return both the columns from this, so that we are able to see what we are getting because of this join. So if I look at my output, so here we have two rows for -1, two rows for 0, two rows for 2. Now once you have the points, then what you can do is you can simply go ahead and calculate the distance between two, since they are along the same axis, right? So you can simply go ahead and subtract and get the absolute value, because we need to calculate the distance, and distance is not negative. So what I'm doing is p1 dot x minus p2 dot x, that is going to give you the distance, and if you get the absolute out of it, it is going to make sure that it is not negative, right? Okay, let me go ahead and let me alias this as distance. Obviously this is just for demonstration purposes. Let me run this now. Now what you have is, you have the distances between. So let me just do this, select star, and then, so that we actually get to know like how the distance was calculated. So distance between -1 and 2 is 3, -1 and 0 is 1. Similarly, we have the distances. Now we need to get the minimum out of this distance. So obviously this entire thing, when you calculate the distance, if you have minimum, right? So if I just remove this, minimum of this is what we need in our output, and this should be aliased as shortest. So as shortest, and if I go ahead and run this, let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how to do it. Also, there is another part of this question. It says that how could you optimize your solution if the point table is ordered in ascending order? So just think about it, right? So again, go to this, and here we have the table. Now if this particular example is actually ordered in ascending order, so -1 0 and 2, and -1 0 and 2. So instead of doing p1 dot x not equal to p2 dot x, what you can do is p1 dot x is less than p2 dot x, or p1 dot x is greater than p2 dot x. Any of the two condition, if you do that, so what you can do is, -1, is it less than -1? No. Is it less than 0? Yes. Is it less than 2? Yes. So for -1, it will have 0 and 2. For 0, is 0 less than -1? No. Is 0 less than 0? No. Is 0 less than 2? So yeah, 2. So you see how the number of rows will decrease. Initially what we had was, for -1 we had 0 and 2, and for 2 also you have -1 and 0. So actually you are calculating distance between -1 and 2, and then 2 and -1 twice, right? So that is what is making it inefficient. So if you do either, if you do either this, or if you do either this, and then run it, it is going to be way faster. But the condition to that is this table should be sorted in ascending order. So this is the 30th video of the series called Employees with Missing Information. And if I look at the companies this question has been asked in, so Adobe a number of times. Okay, let's look at what the question has to say. We are given a table called employees with two different columns, employee ID and name. Employee ID is the column with unique values for this table, and each row of this table indicates the name of the employee whose ID is employee ID. We are also given a second table called salaries with again two different columns, employee ID and salary. Employee ID is the column with unique values for this table. Each row of this table indicates the salary of the employee whose ID is employee ID. Okay, we are asked to write a solution to report the IDs of all employees with missing information. The information of an employee is missing if the employee's name is missing or the employee's salary is missing. Return the result table ordered by employee ID in ascending order. Okay, let's go to the example and see what do we need in our output. So here we have few records for employees table as well as the salaries table, and we need to find out the employee IDs whose either the employee name is missing or the salary is missing. So for example, employee ID 2. There is a name but there is no salary. So 2 should be in our output. 4 has a name as well as a salary. 5 has a name as well as salary. Now employee ID 1 has a salary but does not have a name. So employee ID 1 and 2 should be in our output, and that is what we need to do. At first glance it might look complicated, but this question satisfied the definition of one of the joins that we have learned about in our SQL 50 series to the T, that you have to reach out to another table to see whether there is information related to a particular employee in the salaries table. If not, you keep that employee ID, and then from the other side as well. So from the salaries table you have to reach out to the employee table and try to see whether the person has a name or not. So you say, what does this define? This defines the full outer join. Since in MySQL you cannot do a full outer join just by using the keyword full outer join, so you can emulate it using first doing a left join, then using a right join. For now, let's forget about right join. Let's see, okay, if I need to find out from this employees table what all employees do not have salaries. So how will you do that? So I can go ahead and do from this table called employees aliased as E. If I go ahead and do left join the salaries table aliased as S and join on E dot employee ID is equal to S dot employee ID. Okay, and then let me go ahead and return all columns. Okay, let me now go ahead and run this and let's see which all employees in the employees table do not have a salary associated with them. Okay, let me just drag it above and let's see what do we have in our output. So here, just as we discussed, right, employee ID 2 has a name but does not have any salary associated with the person, right? So to get this person, what I can do is where both the columns coming from the salaries table, any one of them should be null. That means that the person does not have a salary. So if I go ahead and write, because in this I am only concerned about employees who does not have a salary, S dot employee ID is null or salary is none, whatever. So let me just do S dot salary is null. Okay, now if I go ahead and run this, it will only keep the first row. So this is the person who has a name but does not have a salary. Okay, now if I need to do the same thing, but if for all the employees who have a salary, I need to find out whether they have the name or not. So what I can do is, let me just copy this exact same thing, right? Let me just remove the semicolon, exact same thing. However, what I need to do is, in this case, either you can change this to right join. What is a right join? So if I just do right join, right? If I just here replace left with right, this thing, this entire thing is equivalent to writing this. Let me just copy this again and paste. I'm just trying to demonstrate. So this right join, this part is actually equal to this thing. What is basically happening is, from salaries I now want to reach out to employees table to get whether employee ID and name is null or not. So you see, that is what. So either you can use this or you can use this, does not matter. But since we are trying to do a full outer join, in that the definition is have a left join as well as a right join. So I will go ahead with the upper part, right? But just wanted to show you that whether, like, how can you have the alternative approach as well. So right join this, right? So from this employees right join, so basically from salaries, try to reach out to the employees table, and in this particular case, what will be the null part?
the employee ID or the name coming from the employees table. So where e dot name is null. E dot name is null. Or let me go ahead and so this is what we just achieved, right? Let me just remove this part. Let me run this now. Let's see what do we have in our output. Okay, let me just drag it above. So here, if you can see, this is a person, employee ID 1, who has a salary but has no name. So you see, this is why I took e dot name is null. Okay, let me just put it back here. And obviously, if I perform a union of these two, so this is going to return me what? A person who has a name but does not have a salary, and a person who has a salary but does not have a name. Okay, now if I go ahead and look at my output, so this is one. So employee ID 2 has a name but does not have a salary. Employee ID 1 who has a salary but does not have a name. Now in our output, we need to return the employee IDs. So you see, now here you might be thinking, which column should I return? Should I return employee ID from the employee? Because these two columns are coming from employee and these two columns are coming from the salaries table. So employee ID from this or employee ID from this. But if you think about returning employee ID from this employee ID column, so here you can get two, but here you will be having null. But in employee ID coming from the salaries, here you will be having null, but here you can get the one. So can you think about it, like what's the problem that we are facing and how can you resolve this? Yes, we discussed about it. There is a function called coalesce, right? So it what does it return? It returns the first non-null value. So if you coalesce employee ID and employee ID, both these columns, the first non-null value is 2. So it will return 2 in this case. And here it is a null. So the first non-null value would be 1. So you see, now it will return the employee IDs that we want. So if I go ahead and do this, then okay, return coalesce of employee ID coming from e dot employee ID and s dot employee ID, and let me go ahead and alias this as employee ID, right? Because that is what we need in our output. If I go ahead, employee ID. Okay, so now you just need to make sure that before running, here you are returning only one column and here you have 4 different columns. Union won't work. For union to work, you have to return same number of columns having same data type. Remember, so here what you need to do is copy this entire thing, paste it entire thing here, and then what you can do is simply go ahead and run this. Let's see what do we get in our output. Okay, let me just drag it above. So here what we have is employee ID 2 and 1 and expected is 1 and 2. Basically, we saw that we need to sort this also by employee ID in ascending order. So at the end, what we can do is we can simply go ahead and write order by employee ID. Okay, then you might be thinking, won't execute first and then there is a union. So how is this order by working? So actually, if you think about it, we have discussed the order of operations. Order always works after select, right? So what will happen is from this table, it will perform a join and then there is a filtering and then there is a select. So this will work. Then again, from this where select this entire thing, then there is going to be a union, and then after the union is performed, order by the employee ID. So you see, that is how it is going to run and that is how it is able to sort this. So if I go ahead and run this now, let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how to do it. Not a very difficult question, but we have to just employ our understanding of full outer join. And since we cannot do full outer joins directly, what we did was we basically broke that into two halves. Firstly, we performed a left join so that we can get employees who do not have salaries. And then we performed a right join to see employees who have salaries but do not have a name, union the two things together, and then we return the employee ID, but by using a coalesce to return the first non-null employee ID. So this is the 31st video of the series called page recommendations, and if I look at the companies this question has been asked in, so Facebook, let's look at what the question has to say. We are given a table called friendship with two different columns, user 1 ID and user 2 ID. User 1 ID and user 2 ID is the primary key, that is combination of columns with unique values for this table.
Each row of this table indicates that there is a friendship relationship between user 1 ID and user 2 ID. We are also given a second table called likes with again two different columns, user ID and page ID. The combined columns user ID and page ID is the primary key, that is combination of columns with unique values for this table. Each row of this table indicates that the user ID likes page ID. We are asked to write a solution to recommend pages to the user with user ID equal to 1 using the pages that your friends liked. It should not recommend pages you already liked. Return the result table in any order without duplicates. Okay, let's go through this example. So here we have certain records in friendship as well as the likes table. So firstly, what we need to do is who are the friends of user ID equal to 1. So 2, 3, 4 and 6. So user IDs 2, 3, 4 and 6 are the people who are friends of user ID 1. Now let's look at what all pages 2, 3, 4 and 6 like. So 33, 24, 56, 33, 77, 77 and 88. These are the different pages. But if you look at it, user ID 1 already likes page ID equal to 88. So even though user ID 1 friends 6 likes the page ID, we do not need to recommend that. Why? Because it should not recommend pages you already liked. So it should recommend 23, 24, 56, 33, 77. And that is what we have in our output. So to solve this question, the first thing that we should do is let's find out who all are the friends of user ID equal to 1. So if I go ahead and do from the table called friendship, if I go ahead and keep only those rows where user 1 ID is equal to 1, then the person in the user 2 ID is going to be the friend, or user 2 ID is equal to 1, then the person in user 1 ID is going to be the friend. Okay, let me do select star. Let's see who all are the friends of user ID equal to 1. Okay, so if I look at my output, so here it displays the same thing. So 2, 3, 4 and 6 are the people who are the friends of user ID. Now let's wrap this entire thing in a table called T because we need to use that. Okay, now what we need to do is from this table called likes, let's try to get what all pages the friends of user ID equal to 1 like. So what we can do is from this table called likes aliased as L, we need to now here you have all the users and all the pages that they like, but we are only interested in what pages the person likes, the people who are friends of user ID equal to 1. So since we are going to join this table, so only keep the pages liked by the person who is user ID 1 or its friends. So that is why inner join is the best way to go here. So inner join this entire table called T on L dot user ID is equal to, so L dot user ID, let me just drag it down a bit. So either your friend could be user 2 ID or user 1 ID. So L dot user ID is equal to T dot user 1 ID or L dot user ID is equal to T dot user 2 ID. Okay, now what I need to do is let me go ahead and select stars. Let me run this. Let's see if we have the pages liked by the person user ID equal to 1 and its friends or not. So if I look at my output, so here I have, okay, I have the user IDs and the pages liked. So all the people, if you see here, 2, 3, 4 and 6, 2, 3, 4 and 6, right? Everywhere all you see is 2, 3, 4 and 6 in user ID, in user 1 ID, user 2 ID, right? So here what we have is basically all the pages liked by either the user ID 1 or its friends. Okay, now what we need to do is we only need to keep those page IDs which are not already liked by the person user ID 1. So how can we do that? We can simply perform a filter function that, hey, from this, only keep those rows where page ID, right? So page ID is coming from the likes table. So I can just go ahead and do L dot page ID is not in, right? Page ID not in, and then select page ID from the likes table, from likes table where your user ID is equal to 1. What is this going to do? Right? What this entire thing is basically finding. So from this likes table,
what all pages are already liked by user ID 1. That page ID we do not need to recommend if one of the friends like that page as well. If I go ahead and run this, let's see what do we get in our output. So if I now look at my output, so here we have, okay, only those pages which are liked by the friends of user ID equal to 1 and are not liked by user ID 1 already. So 88 was such an example. So once we have this, then all we need to do is keep the distinct page IDs. So at the end, what we can do is, let me just drag it down. Here we can simply go ahead and return distinct page ID, and this should be aliased as whatever is required in our output, which is recommended. So recommended page. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. This is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how to do it. Not a very difficult question, but yeah, you have to basically do an advanced join where what you need to do is, firstly, we found out who all are the friends of user ID equal to 1. Then we use the likes table to actually get, okay, the person user ID equal to 1 and his or her friends, what all pages do they like. So this is what we got here. And then since the question says that we are only to recommend those pages which are not already liked by the person, so we ignored all that or excluded all those pages and then simply went ahead and return the distinct page IDs and alias this as recommended page.
So this is a 30-second video of the series called Tree Node, and if I look at the companies this question has been asked in, so Microsoft and Twitter a number of times. Let's look at what the question has to say. We are given a table called tree with two different columns, ID and PID. ID is the column with unique values for this table. Each row of this table contains information about the ID of a node and the ID of its parent node in a tree. The given structure is always a valid tree. Okay. Each node in the tree can be on one of the three types. Leaf if the node is a leaf node, root if the node is a root of the tree, inner if the node is neither a leaf nor a root node. We are asked to write a solution to report the type of each node in the tree. Order of the result does not matter. Okay, let's go through this example. Let's look at the tree. So obviously this is the root, the parent of every other node, and then these ones 3, 4 and 5, because there is no other nodes they are connected to, so they are the leaf nodes, and nodes like 2 who has a parent but they are a parent of other nodes as well, so they are inner nodes. One is the root node, and then 2 is a node who has a parent 1, right? So 2 has a parent 1 but is also a parent of 4 and 5, so 2 should be inner, then 3, 4 and 5 should be the leaf node, and that is what we have in our output. Okay, so to solve this question, what we need to do is we basically need to use the case when statements to make sure that we capture all the cases when a node can be root, leaf or inner. So what we need to do is, from this table called tree, we need to have the ID column, because in our output we need the ID column, and then we need to create a column called type. So return ID and then use the case when statements, that case when parent ID is null. What does this mean? So you are the parent of everyone else and you do not have a parent, right? So for nodes like 1, so is null, then you are the root node, right? So when you are the root node, when your parent ID is not null, right? So when parent ID is not null, that means you have a parent but you also are a parent of someone else. For example, IDs like 2. So you have a parent but you are also a parent of other nodes. So that means, so and ID in, and then you can do return distinct parent ID from tree. So what does this will do? So this entire thing will say, okay, 1 and 2 are basically the different parent IDs, and yes, 2 is in 2, so that means this is an inner node. So then inner, or the third condition that remains is that you are not a parent of someone else, so that means you are the leaf nodes. So you simply write else leaf. Since you started a case when statement, you need to end this as well, and then you need to alias this as whatever is required in our output. So this should be type. So as
type. And since we do not need to order this by anything else, so let me go ahead and run this. Okay, so let's see what do we get in our output. So yeah, here we see wrong answer. That is because we just need to, capitalize this thing R. Okay, let me go ahead and run this again. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. Not a very difficult question. All we had to do was from this table, right? From this table, what we need to do is basically if your parent is null, that is you are the parent of everyone else, but you do not have a parent. So that means you are the root node. If you have a parent, but you are also a parent, then you are the inner node. And if you have a parent, but you are not a parent of someone else, then you are the leaf node.
So this is the 33rd video of the series called Gameplay Analysis Part 3. And if I look at the companies this question has been asked in, so GSN Games, let's look at what the question has to say. We are given a table called activity with four different columns: player ID, device ID, event date, and games played. The combined column player ID and event date is the primary key, that is column with unique values of this table. This table shows the activity of players of some games. Each row is a record of a player who logged in and played a number of games, possibly zero, before logging out on some day using some device. We are asked to write a solution to report for each player and date how many games played so far by the player, that is the total number of games played by the player until that date. Check the example for clarity. Order of the result does not matter. Okay, let's go through this example and see how the output should look like given this records. So you have two different players, player ID 1 and 3, various devices and various dates, and we need to calculate for every player ID and every date what is the total number of games played so far. So for player ID 1 and 1st of March 2016, the total games played are 5. Now for player ID 1 and 2nd of May 2016, the total games are 5 plus 6, 11. And then for player ID 1 and 25th of June 2017, 5 plus 6 plus 1, that is 12. Similarly for player ID 3, and that is what we have in our output. So basically this is an example of calculating running totals. Now we have learned that running totals, moving averages, etc. can be calculated using both joins as well as using window functions. I have already explained in my SQL 50 series how to calculate with running total without using window functions, using just joins. If you want to solve this question without using any window function, if you want to learn the trick, you can watch this. The link will be in the description box below along with the SQL playlist. But yeah, let's try to solve this question. It's exactly the same question, but we need to find out how can we solve this using a window function. Okay, so what we need to do is from this table called activity, we need to in our output return the player ID and event date. So we can say, okay, return me player ID and event date, and then we need to calculate this column games played so far using a window function. Okay, so for every player we need to create a partition, because for player ID 1 these three rows should be used to calculate at a particular date what is the total games played so far. Okay, so and which column we are going to actually use to calculate the total games played? The games played column. So sum the games played column, and then since we're writing a window function, we always need to write the over clause, and then we need to create partitions by the player ID, and then you also need to order by the event date. Why? Because so that for example, if you consider these three rows, so it is ordered in event date. 1st of March comes first, then 2nd of May, then 25th of June, so that as you go down this partition, you can keep on adding the games played to get you the total number of games played so far on that particular date. So once you have this is going to calculate the total games played, and we can alias this as whatever is required as our output. So as games played so far. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. So yeah,
Somewhat tricky question where you can also use the joins to solve this question, but right now I am using a window function. What we simply did was we just did that. Okay, for every player ID we created the partition, because for every player ID we need to get for a particular date what is the games played so far. We use the window function, sum the game played over partitioned by the player ID, arranged in event date in ascending order, and got the output. So this is the 34th video of the series called Grand Slam titles, and if I look at the companies this question has been asked in, so Amazon, let's look at what the question has to say. We are given a table called players with two different columns, player ID and player name. Player ID is the primary key, that is column with unique values for this table. Each row in this table contains the name and ID of a tennis player. We are also given a second table called championships with 5 different columns. Year, Wimbledon, French Open, US Open, Australian Open. Year is the primary key column with unique values for this table. Each row of this table contains the IDs of the players who won each tennis tournament of the Grand Slam. Okay, we are asked to write a solution to report the number of Grand Slam tournaments won by each player. Do not include the players who did not win any tournament. Order of the result does not matter. So let's go through this example. So here we have three different players: Nadal, Federer, and Novak, and in various years who won the Grand Slam. Okay, so just looking at it, so player ID 1, that is Nadal, won how many Grand Slam titles? 1, 2, 3, 4, 5, 6, 7. So in total 7. Federer won 1, 2, 3, 4, 5. So 5 Grand Slam titles. And player ID 3, Novak, did not win any Grand Slam titles. So that should not be in our output. So Nadal 7, Federer 5. And that is what we have in our output. So to solve this question, there are two ways, a longer way and a shorter way. The longer way is that what you can do is you can try to unpivot this champions table so that you have one column which has all the player IDs. You can change this wide table into long format. So you can have two columns, one is year and then winner, and then have 2018 1, 2019 1, 2022, and then 2018 1. This is for French Open, 2019 1, 2021, then for US Open, and so on. Once you have that in a long form, that you can simply group by this particular column, and if you count star, that is going to give you the number of counts for each player ID, and at the end you can join it to the players table to get the player name. That is a longer way. But a shorter way is using the cross join. So what we need is, for every particular player ID and player, let's get all the possible combinations using the cross join, and then use that to actually get the number of wins in total. So what I'm saying is, from this table called players alias as P, let me cross join the championships table alias as C, and let me select all the rows. Okay, so select star. Let me go ahead and run this. Let's see what do we get in our output. So if I look at my output, let me just drag it to the left so that it's easier for us to read. Okay, so this is what we have for every player, all the possible combinations. Then just by looking at it, if I want to find out for all these different players how many times they have won the Wimbledon. So if I do this thing, right? So look closely, group by the player ID and player name is coming from the players table. So P dot player ID and P dot player name. And if we need that in our output, right? So P dot player ID and P dot player name. And then what if I do this? So basically I'm counting the number of Wimbledon wins. So Wimbledon is equal to P dot player ID, and Wimbledon is coming from championship. So C dot Wimbledon is equal to player ID, and let me alias this as wins. Okay, let me go ahead and run this. Let's see what do we get in our output. So here we have for every player ID and player name how many times they win Wimbledon. So if you just compare this, right, just compare this with here. So here what we have is, so if you look at it, right, so Wimbledon, player ID 1, Nadal has won twice in 2018 and 2019. In 2020, Federer won so once, and Novak did not win it any number of times. So that is what you have here. So you see, what you are basically doing is, you are comparing the player ID, right? So you are comparing the player ID with the whether they won the title or not, right, in any particular year. So to know all the total Grand Slam titles, you can basically extend this, that hey, this plus when your French Open is equal to player ID plus US Open is equal to player ID plus Australian Open equal to player ID. So let me go ahead and inculcate that here. So let me just drag it to the left and here so that it's easier for me. Okay, plus and okay. So if I now look at my output, right? So what I'm doing is so here we have, okay, so player ID Novak has won 0 Grand Slam titles, Federer 5, Nadal 7. In a question, it says that do not include players who did not win any tournament. So since we grouped by this, and basically what we can do is we can include only those rows where Grand Slams count is greater than 0. So having Grand Slam counts greater than 0. That means if I go ahead and run this, okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. This is accepted and this is how to do it. Somewhat tricky question, and there are two different ways. One is using union all and then grouping by. Second one is using a cross join. I hope this made sense. What we are basically doing is we are performing a cross join and then using the sum. So basically what is this going to do? It checks and returns a boolean value. If it is true, then you sum those things up. So that is going to give you the total number of Grand Slam titles won.
So this is the 35th video of this series called Leetflex Bank Accounts, and if I look at the companies this question has been asked is audible. Let's look at what the question has to say. We are given a table called login for 4 different columns: account ID, IP address, login and logout. This table may contain duplicate rows. The table contains information about the login and logout dates of the Leetflex accounts. It also contains the IP address from which the account was logged in and logged out. It is guaranteed that the logout time is after the login date. We are asked to write a solution to find the account ID of accounts that should be banned from Leetflex. An account should be banned if it was logged in at some moment from 2 different IP addresses. Order of the result does not matter. Okay, let's go through this example. So here we have records of 4 different account IDs and different IP addresses, and when did they log in and log out, and we need to find out all those accounts who were actually logged in at the same time from 2 or more different IP addresses, and that are the accounts that needs to be banned. So just look at it, right? So let's look for account ID 1 and 2, and we can extend it to 3 and 4 as well. But if I look at account ID 1, on 1st of February 2021, between 9 a.m. and 9:30, this person was active from IP address 1, and on the same date, between 8 a.m. and 11:30 a.m., this person was logged in from IP address 2 as well. So basically, this person logged in at 8 a.m. from IP address 2, and then at 9 a.m. from another IP address, and then logged out, and then finally logged out from the IP address 2 at 11:30. So basically, during the duration 9 a.m. to 9:30, the person was logged in from both IP address 1 and 2. So obviously 1 is something that needs to be banned. But you look at account ID 2, even though they look exactly the same, but the dates are different. If you pay close attention, this is 1st of February and this is 2nd of February. So during the same time, the person was not logged in from 2 different IP addresses, even though the next day the person logged in from the different IP address. So 2 should not be in the output. Similarly for 3 and 4. So that is what we have in our output. So to solve this question, what we need to do is, firstly, for every account ID, we need to compare, okay, what all different IP addresses the person has logged in from, and whether the login time of one coincided or is in between the login and logout time of the other. So to better explain this, what we can do is, let's move to the Excel sheet and let me just take the account ID 1 and 2 column and see how can we solve this. So if we take this login for table and create another version of it, so let's say this is L1 and this is L2, and let's say we perform a inner join of these two based on account ID is equal to account ID, but your IP address is not equal to IP address. Why? Because we need to make sure that, okay, this a particular account ID has the person logged in from another IP address. So what we can do is, let's try to join this. So what I'm doing is, from this table called log info aliased as L1, let me inner join the log info table, this time aliased as L2. What this is called? This is called self join on L1 dot account ID is equal to L2 dot account ID. Let me just drag it to the left so that, okay, L2 dot account ID, and then and L1 dot IP address is not equal to L2 dot IP address. Just so that, so if I go here, right, so if I don't do L1 dot
IP address is not equal to L2 dot IP address. If you just do simply on account ID, what it will have? It will have unnecessary rows. Why? Because it will try to find, okay, account ID 1. Here it will find two different matches. But this row is exactly same as this row, and you do not need to compare a row with itself, right? So that is why I'm doing account ID is equal to 1, but IP address 1 is not equal to IP address of 1 in this particular row. So this row will be ignored, but this will be kept. Similarly for this, it will compare and try to keep this row. So once you have this is what the table you will have. Okay, so now once we have this, then we need to check that, okay, whether the login of the person from IP address 1 is between the login and logout of the IP address second one. Similarly for this, and why do we need to have? So here if you look at it, right, so here we are basically doing a comparison twice, but firstly we are comparing IP address 1 with 2 and then 2 with 1. Person is already logged in IP address 2 between 8 and 11:30, and from IP address 1 the person logged in between 9 and 9:30. But in some cases it can be reversed, right? So we need to check both the cases. So we are only, after performing this join, we are only interested in those rows where your login is between login or logout, or your logout is between login and logout. Okay, so what we can do is keep only those rows where L1 dot login is between L2 dot login and L2 dot logout, whether this one or same stuff, but we need to compare the logout part. Okay, so or L1 dot logout is between L2 dot login and logout. Okay, so once we have this, so for example in this case, right, so here is this between this? Yes, so this entire row will be kept. So let me just highlight it with green, let's say. Okay, will this be kept? 8 is not between 9 and 9:30, and 11:30 is again not between 9 and 30, so it won't be kept. Similarly, these two are two different things, so the only rows in this is going to be kept is this one. Okay, once we have this, then similarly we will be having for 3 and 4 as well. Then what we need to do is we basically need to return the distinct account IDs. So what we can do is simply write is return distinct L1 dot account ID. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. So yeah, somewhat tricky question, but what we had to do is we can, self join a table on it itself, so that we are able to compare for a particular account ID if the person has logged in on two or more different IP addresses, whether the login and logout times are coinciding or is one is between the other. So once we have that, then we only kept those certain rows, and then we return the distinct account ID.
So this is the 36th video of the series called Students with Invalid Departments, and if I look at the companies this question has been asked in, so Amazon, let's look at what the question has to say. We are given a table called departments with two different columns, ID and name. In SQL, ID is the primary key of this table. The table has information about the ID of each department of a university. We are also given a second table called students with three different columns, ID, name and department ID. In SQL, ID is the primary key of this table. The table has information about the ID of each student at a university and the ID of the department he/she studies at. We are asked to find the ID and name of all students who are enrolled in the departments that no longer exist. Order of the result does not matter. Okay, let's go to this example and look at what we need in our output. So let's look at the records in the department table. So there are three different departments: electrical engineering, computer engineering and business administration, and there are a number of different students, their IDs, name and the department they are enrolled in. So to solve this question, we can adopt two routes. Firstly is performing a join. So if you just think about it, right, so if you perform a left join of students table with the departments table and say that, okay, where your department ID is equal to ID, obviously these are the departments which exist right now. So students who are enrolled in departments which are not present in the departments table, that is going to be null. For example, if you look at John, right, department ID 14, department ID 40 does not exist anymore. So here everything that will come will be null. So you can perform a join and say, okay, wherever your columns coming from the departments table is null, keep only those rows. That is one way. But since this, if you look at it, this question is regarding the subqueries. So what we need to do is we can solve this using a subquery as well, and we can directly go ahead and do from this table called students, keep only those rows where department ID does not belong to the ID in the department table, because those are the departments that no longer exist. So, and that if you do that, that is what you get. For example, John, right? So just we looked at it, John 14 department ID does not exist. Similarly for Diana, if you look at it, department ID 33 is not present in the departments table. So to solve this question, what we can do is from this table called students, we are only interested in those rows where department ID department ID is not in, and then we can get the list of all the department IDs from the departments table. So return ID from the departments table, right? So this is going to give you, so if I just format it in a better way, so this entire thing is going to list off all the departments that exist, and then we are in from the students table keeping only those rows where department ID does not belong to the department IDs that exist. So what are we basically saying? Return all the departments that do not exist, and for them in our output we need the ID and the name. So we can just go ahead and write return ID and name. Since we do not need to order this by anything, let me go ahead and run this. Let's see what do we get. So this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. Not a very difficult question. All we had to do was from the students table, what we did was we only kept those rows where department ID does not belong to any ID that is already existing in the departments table. And that is how we do it. So this is a 37 video of this series called Find the Team Size. And if I look at the companies this question has been asked in, so Amazon, let's look at what the question has to say. We are given a table called employee with two different columns, employee ID and team ID. Employee ID is the primary key, that is column with unique values for this table. Each row of this table contains the ID of each employee and their respective team. We are asked to write a solution to find the team size of each of the employees. Order of the result does not matter. Okay, let's go through this example. So here we have various employees and their team IDs, and let's look at, okay, so for employee ID 1, the team they belong to is team ID 8, and in team ID 8 there are three different people. So employee ID 1, the team size is 3. Similarly for employee ID 2, again belongs to team ID 8, so the team size is 3, and so on. And that is what we have in our output. So to solve this question, what we can do is, firstly, we can take this employee table and group by the team ID and count the number of employees. That will give you the team size of every team ID. So what I'm saying is, from this table called employee, let's group by the team ID and return the team ID and count the employee ID. That will give you the team size, right? So in our output we need that as team size. So let me write this as team size, and if I go ahead and run this, let's see what do we get in our output. Okay, so if I look at my output, so I have team ID 8, 7 and 9, which has team size 3, 1 and 2. Now what I need is, basically in this employee table, if I left join this employee table using team ID from the table that we just created. So what I'm saying is, let's keep this entire thing as a table T. So if I just wrap this around parentheses and alias this as T, and what I do is, from this table, from the table called employee aliased as E, if I do left join the table that we just created, which basically is for every team ID what is the team size, on E dot. So since your employee table also has the team ID and the team and the table that you created also has team ID, so we can simply use that column to join. So E dot team ID is equal to T dot team ID, and then in our output what we need the employee ID from the employee table. So return E dot employee ID, and we need the team size. Team size is coming from capital T dot team size, and since we do not need to order this by anything, so I think this looks good. This is the subquery, since this question belongs to the subqueries part. Okay, so let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted and this is how to do it. Not a very difficult question. What we did was, so initially we grouped by the team ID to get the team size, and then we simply joined this on the employee table on the team ID column so that we can get for every employee ID what is the team size. So this is the 38th video of the series called Gameplay Analysis Part 2. And if I look at the companies this question has been asked in, so GSN Games, let's look at what the question has to say. We are given a table called Activate with 4 different columns: player ID, device ID, event date, and games played. The combined columns player ID and event date is the primary key, that is combination of columns with unique values of this table. This table shows the activity of the players of some games. Each row is a record of a player who logged in and played a number of games possibly 0 before logging out on some day using some device. We are asked to write a solution to report the device that is first logged in for each player. Order of the result does not matter. Okay, so let's go through this example. Here we have different records for 3 different player IDs, their devices, event dates, and the number of games played. And for every player ID, we need to return the device on which the person first logged in. So for example, player ID 1, the first login was on 1st of March 2016 on the device ID 2. Similarly, since there is only one row for player ID 2, so this is the device where the first login. Then for player ID 3, the first login was on 2nd of March 2016 on device ID 1. So 1, 2, 2, 3 and 3, 1, and that is what we have in our output. So to solve this question, what we can do is we can use our window functions to actually rank. So for every player ID, order by the event date, and then rank that, okay, this was the first login, this was the second login, and so on. And then once we have that first logins and second logins, then we can only keep those rows where the login was the first or the earliest login, and what is the device ID associated with that. Okay, so what I mean by that is, let's start with from the table called activity. Let's keep all the columns. So select star, and then I'm going ahead with dense rank. The reason being that if on the earliest date of login, the person logged in with 2 or more devices, then both of them devices are captured in our output. So dense rank over, and then for every player we need to find it, right? So partition by player ID, order by the event date in ascending order, ASC, or you cannot write it by default, it's ascending order. And then let's alias this as rank. Okay, let me go ahead and run this. Let's see what do we get in our output. So if we look at our output, so let me just drag it to the left. So for every player ID we have, okay, this is the first login date, so rank 1, then rank 2, similarly for 2 and 3. Okay, now once we have this, then we are only interested in the earliest logins, which means rank is equal to 1. So this entire thing can be a subquery to create this table, right? So from this entire thing is a subquery to create the table which actually has the rank to know the earliest login. So let me alias this as table T, and then we are only interested in those rows where T dot rank is equal to 1, right? So T dot rank is equal to 1, and let me just do select star. Okay, so if we look at it, so we are only interested in the earliest. So for player ID 1, the earliest login was 1st of March, similarly for 2 and 3. Now once we have this, then we only need the player ID and the device ID. So we can simply go ahead and write T dot player ID and T dot device ID. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted and this is how to do it. Not a very difficult question. All we had to do was, firstly we found out, so for every player ID, what is the earliest login date by using the dense rank to rank. And then we are only interested in the earliest date, so we kept rank is equal to 1 because that is how we ranked. And then for them we just returned the player ID and the device. So this is a 39th video of the series called Department Highest Salary. And if I look at the companies this question has been asked in, so Amazon, Google, Adobe, a number of times. Kind of an important question. Let's look at what the question has to say. We are given a table called employee with 4 different columns: ID, name, salary, and department ID. ID being the primary key for this table. Department ID is a foreign key, that is reference column of the ID from the department table. Each row of this table indicates the ID, name, salary of an employee. It also contains the ID of their department. Okay, we're also given a second table called department, 2 different columns: ID and name. ID being the primary key for this table. It is guaranteed that department name is not null. Each row of this table indicates the ID of the department and its name. We are asked to write a solution to find the employees who have the highest salary in each of the departments. Order of the result does not matter. Okay, let's go through this example and see what we need in our output. So here we have various records for the employee table and the department table. So let's look at, okay, there are 2 different departments, IT and sales. In IT, what is the highest salary? So 90,000 is the highest salary, but that is for two people, Jim and Max. So for IT, Jim and Max, and the highest salary being 90,000. For sales, what is the highest salary? 80,000 for Henry, and that is what we have in our output. So since in our output we need the department name and then the employee name and the salary, which are in two different tables, so the first thing that we should do is we should join these two tables using the department ID column of the employee table and ID column of the department table. So what we can do is we can go ahead and do from this table called employee aliased as E, let me left join the department table aliased as D on E dot department ID is equal to D dot ID. Okay, and then what all columns do we require in our output? We need the name of the department, name of the employee, and the salary. So what we can do is we can keep only those rows which we require. So select E dot name, and that should be as employee, and then we also need the department name, right? So D dot name as department, and then what we need is we also need the salary part, E dot salary, and let's keep the department ID column as well. So E dot department ID. Let me go ahead and run this. So if we look at our output, we have employee, then the name of the department, the salary, and the department ID. So now what we can do is we can use our ranking methods, rank, dense rank, or row number to actually partition by every department and then rank based on the highest salary as rank 1, then rank 2, and so on. So what we can do is we can write, okay, use the dense rank. Why we are using dense rank rather than row number? So here you can use rank or dense rank, any of them, but the reason being, so here you just saw, right? So for example, in this case, for ID, department ID 1, that is ID, there are two people who have the same salary, so both of them are required in our output. So if you use row number, even if there is a tie, it assigns a different rank. So row number cannot be used, rank can be, and dense rank can be. I usually like to go with dense rank. So dense rank over, we need this for every department ID. So partition by E dot department ID. You can also do it by name of the department as well, but better doing using department ID, and then order by the salary part. So E dot salary in decreasing manner, and then this entire thing could be aliased as rank. So as rank, let me go ahead and run this. Let's see what do we get in our output. So if we look at our output, so this is what we have. So for IT, this is the first highest salary, 90,000, and this is the second highest. And for sale, this is the first highest, this is the second highest. So once we have this table, then what we can do is we can wrap this entire thing into parentheses. So from this entire thing, which produces this current table that we see on the screen, we are only interested in the highest salary. So where rank is equal to 1, and then what are the columns that are required in our output? We only need the employee and salary. So return T dot department, T dot employee, and T dot salary. Okay, I think this looks good. Okay, so let me go ahead and run this. Let's see what do we get in our output. So this is accepted. Our output is same as expected output. Let me go ahead and submit to pass all the test cases. This is accepted, and this is how to do it. Not a very difficult question, but what we had to do is firstly we join the employee table with the department table so that we can get the name of the department as well, and then we ranked by the decreasing order of salary for every department ID so that we can get the, okay, this is the first highest, this is the second highest based on every department. And then since we are only interested in the highest salary, so we kept only those rows where rank is equal to 1, and then we return the desired columns. So this is the 40th video of the series called the most recent orders for each product. And if I look at the question, this question says that we are given a table called customers with two different columns, customer ID and name. Customer ID is the column with unique values for this table. This table contains information about the customer. We are also given a second second table called orders with 4 different columns: order ID, order date, product ID, and customer ID. Order ID is the column with unique values for this table. This table contains information about the orders made by customer ID. There will be no product ordered by the same user more than once in one day. We are also given a third table called products with 3 different columns: product ID, product name, and price. Product ID is the column with unique values for this table. This table contains information about the products. Okay, we are asked to write a solution to find most recent order of each product. Return the result table ordered by product name in ascending order. In case of a tie, product ID in ascending order. If there is still a tie, by order ID in ascending order. So yeah, let's go through this example and see what we need in our output. So here we have various records of customers in the customers table, orders in the orders table, as well as products in the products table. So just by looking at it, the first insight that we have is we do not need customers table to solve this question, because if you look at in our output, you do not need anything from the customers table. For orders table, if you look at for every product ID, so for example product ID 1, so there are 1, 2, 3 and 4 different orders. And if you look at the latest or the most recent one, so this was on 31st of July 2020, this is 29th of July 2020, this is 1st of August 2020 and 1st of August 2020. So for product ID 1, 6 and 7 order ID on 1st of August 2020 are the most recent order. And if we look at product ID 1 is keyboard. So similarly, we can say that, okay, product ID 1, keyboard, order ID 6 and 7, the most recent. So to solve this question, what we can do is, firstly, we can use the orders table, partition by the product ID, order by the order date in descending order, and rank them so that the most recent one is assigned rank 1, then the next recent, and so on. And once we have that figured out, then since in our output we need the name of the product which is in the products table, so we can join with the products table to get the product name. So let's start doing this. So from this table called orders, all the columns, right, select star, and then we need to use ranking to basically rank the most recent orders for each product ID. Now we know there are 3 different ways of ranking in SQL: dense rank, rank, and row number. Because we just saw, and we also learned this in our previous video, because there is a tie, there can be ties. Row number is not the best solution here, so you can either use rank or dense rank. I usually prefer dense rank, so I will go ahead and write dense rank, and then for every product ID we need that, right? So since we are writing a window function, we need to write over clause, over partition by product ID, order by order date in descending manner, because we want the highest or the most recent order date and the top. And let me alias this as RNK, which is rank. Let me go ahead and run this. Let's see what do we get in our output. So here do we have that for every product ID, this one is the most recent, then for product ID 2, this one is the most recent, and so on. Now in our output, we also need the product name, as we saw. So what we can do is this entire thing can be aliased as a table called T. So from this table called T that we just created using this subquery, so let me alias this as T. I need to left join the products table aliased as P on T dot product ID is equal to P dot product ID, right? T dot product ID and P dot product ID. If I go ahead and look at this table, so P dot product ID, in our output, what do we need? We need the product name. So let me just drag it to the down and let's see. Okay, let's keep the columns that are required in our output. So return product name. Product name is in the products table. So P dot product name, and we need the product ID, then T dot order ID and T dot order date. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. Okay, so still not complete yet, because if I just, let me just drag it again to the left and above. So this is what we have. So we have for every product and all the orders, their order date, order ID, product ID, etc. But we do not need that. We only need the most recent. So let me just, do one thing again here, because we also use the ranked, right? So to get the most recent one. So T dot rank, let me keep that column as well.
So this is where what we have. So from this output, what we can do is we can say that, okay, only keep those rows where rank is equal to 1, because that is going to give you for every product ID the most recent order and the details that we need in our output. So what we can do is where t dot rank is equal to 1. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so if we look at now our output looks so, okay, for every product ID, the name of the product, order ID, order date. Obviously, we do not need our rank column now in our output. So this was just for demonstration purposes. So what we can do is we can remove t dot rank from this. And then we also need to order this in case of ties. So we need to order this by product name. So order by p dot product name. In case of a tie, then t dot product ID. Let me go ahead and run this. Let's see what do we get in our output. So yeah, if you look at it, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. Yeah, this is accepted and this is how to do it. So somewhat tricky question, because even if the customer's table is given to you, you do not need to use this to arrive at the solution here. And then what we did was we used the orders table to basically get the most recent order of each of the products. And then we joined it on the products table to get the name of the product, kept only those rows where rank is equal to 1, basically means the most recent order date, and then kept the required column. So this is the 41st video of the series called the most recent 3 orders, and let's look at what the question has to say. We are given a table called customers with 2 different columns, customer ID and name. Customer ID is the column with unique values for this table. This table contains information about the customers. We're also given a second table called orders with 4 different columns, order ID, order date, customer ID and cost. Order ID is the column with unique values for this table. This table contains information about the orders made by customer ID. Each customer has 1 order per day. Okay, we are asked to write a solution to find the most recent 3 orders of each user. If a user ordered less than 3 orders, return all of their orders. Return the result table order by customer name in ascending order, and in case of a tie by customer ID in ascending order, and if there is still a tie, order by order date in descending order. Okay, let's go through this example and see what do we need in our output. So here we have various records of various different customers in customers table as well as different orders in the orders table. So we need to return for every customer the latest 3 orders. So if we take customer ID 1, right? So customer ID 1, we have 1, 2, 3 and 4 different orders. And what are the latest 3? So this was on 31st of July 2020, this was on 10th of June 2020, this is 3rd of August 2020, and then this is 15th of July 2020. So the most latest is 3rd of August 2020. After that, we have 31st of July 2020, and the third latest is 15th of July 2020. So for customer ID 1, these are the 3 that we need in our output, and similarly for other customers. So if we look at our customer ID, right? So if we look at our customer ID 1, then we have the 3rd of August, 31st of July and 15th of July. So to solve this question, what we need is, firstly, since the customer name is not in the orders table but it is in the customers table, and we need that in our output, and along with customer ID, ordered ID and order date, which are actually in the orders table. So we know that we need to join these 2 tables, but instead of joining initially, what we can do is, firstly we can try that, okay, let's take the orders table, partition by the customer ID, order by the order date in decreasing manner, and try to rank these orders from the most recent to the least recent. So that once we have that, then what we can do is we can join with the customers table on the customer ID column to get the name, because we need the name in our output, and then only keep those rows where the rank or the most recent 3 orders are present. And how can we get that? The rank would be less than or equal to 3, because that is how we are ranking from most recent to least recent. Okay, so what I'm saying is, let me just drag it to the left, so and drag it down so that we are able to write it. So what I'm saying is, firstly, let's try to find out for every customer ID what are the ranks associated with the orders. So from this table called orders, let me keep all the columns, and in the output we do not need the cost, right? We need the order ID. Yes, we need the order date, customer ID and customer name, right? So we only need the first 3 columns. So let me just try to keep only those. So I need the order ID, I need the order date, and I also need the customer ID, and then let me go ahead and make a ranked column. So there are three ways of ranking: rank, dense rank, and row number. Dense rank, and then since we are writing a window function, we need to write the over clause, and for every customer ID we need it, right? So partition by customer ID, and then order by order date in decreasing manner, right? So decreasing, and let's alias this as rank. Let me go ahead and run this. Let's see what do we have in our output. So if I drag it above and let's look at our output. So here we have for every customer ID, this is the, as we just saw, right? So this is the most recent, this is the second recent, third recent, fourth recent, and so on. So we have this for every customer ID. Now what we can do is, we got this table, right? So from this, we can wrap this around parentheses, which will basically become our subquery, right? So from this entire table, let's alias this as table T. We need to join with, right? So as T, we need to left join with the customers table. Why we are doing this? Customers table aliased as C on T dot customer ID is equal to C dot customer ID. The reason we are doing it, because we need the name of the customer in our output, right? So if you look at it, customer name is required. So once we join this, what are the different columns that we need in our output? So we need the name, right? And it should be, so return C dot name, and this should be aliased as customer name, right? So as customer name, and then what we need is customer ID, order ID, and order date. So T dot star. For now I'm keeping star because we also need this rank for demonstration purposes. In the final output we do not need it, but let me just go ahead and run this so that I can demonstrate you. Okay, so if we look at our output, so here this is what we have right now. Let me just drag it to the left and above so that we are able to see it properly. Okay, so now we have customer name, order ID, order date, customer ID, and the rank. Now we are only interested in the most recent three, so we can keep only those rows where rank is less than equal to 3. So if I go ahead and write where T dot rank is less than equal to 3, and if I now go ahead and run this, let's see what do we get. Okay, so now what we have is for every customer ID, the most recent 3 orders. Okay, now once we have this, then we do not need this rank column, and we also need to reorder these columns. So what I'm saying is customer name. So this is the first column that we need in our output. Then what we need is, we also need the customer ID. So T dot customer ID. Then we need the order ID. So T dot order ID. And then we need the T dot order date. So T dot order date. Okay, now let me go ahead and run this. Let's see what do we get. Okay, so now what we have is, our output is this. Now we also need to sort this by 3 different columns. So firstly by customer name, right? So let me just drag it down. So we need to write, okay, order by customer name, then by, if there is a tie, then by customer ID. So T dot customer ID, and again by T dot order date in descending order. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so if I drag it above, so this is what we have. Our output is accepted. If we look at our output is same as expected output. Let me go ahead and submit it so we passed all the test cases. So yeah, this is accepted, and this is how to do it. So yes, somewhat tricky, but like, yeah, very similar to the questions that we have been solving lately. So what we did was, firstly we tried to get, okay, what is the rank assigned with the most recent for every customer ID. We got that, and then we joined with the customers table on the customer ID column so that we can get the customer name in our output. And then we only kept those rows where rank is less than equal to 3, because we require the most recent 3 orders of each user. And then we ordered by the customer name, customer ID, and order date in decreasing manner.
So this is the 42nd video of the series called maximum transaction each day, and let's look at what the question has to say. We are given a table called transactions with 3 different columns: transaction ID, day, and amount. Transaction ID is the column with unique values for this table. Each row contains information about one transaction. We are asked to write a solution to report the IDs of the transactions with the maximum amount on their respective day. If in one day there are multiple such transactions, return all of them. Return the result table ordered by transaction ID in ascending order. Okay, let's go through this example. So here we have various records in the transactions table. So for example, if we look at it, right, so on 3rd of April 2021, there is only one transaction, the amount is 57. So highest amount is 57 on 3rd of April, and transaction ID 8 should be in our output. On 28th of April, there are two different transactions of 21 and 40 units. So obviously the highest is 40. So transaction ID 5 should be in the output, but not 9. So if we look at in our output, 5 is there, but not 9, 8 is there, and so on. So to solve this question, what we can do is we can take this transactions table and then partition by the day, right? So you see here, this is a date time. So for time, we do not care. So what we can do is we can format this day column so that it only has year, month, and day, and then partition by that, arrange by amount in descending order, and try to rank it so that the highest amount is ranked 1 and then the next highest amount, and so on. So that once we have that, then we can keep only those rows where rank equal to 1, because that is going to have the maximum amount on that particular respective day. So yeah, to solve this question, let's do from this table called transactions, right? So from this table transactions, if I keep all the columns, so select star, and then what I'm going to do is use the ranking method. So dense rank, and then over partition by, so for every particular day we need it, right? But in before partitioning by the day, we need to remove this time part. So what we can do is we can use the date format function. So date format, what we are going to do is take the day and then convert it into only year, month, and day, so that the time is ignored, and then order by amount in decreasing manner, and let's alias this as rank, right? Okay, now let me go ahead and run this. Let's see what do we get in our output. So if we look at our output, so here we have on 3rd of April 2021, this is the highest one, and we see on 28th of April there are two different transactions, 40 and 21. Obviously this is the highest, and so on. Now from this, what we can do is whatever that we got, this table that we got from this query, we can use this as a subquery. So from this table that we just got, and this is our subquery, let's alias this as table T. We are only interested in keeping the maximum amount. So where T dot rank is equal to 1, and in our output we only need the transaction IDs. So return the transaction ID. So select T dot transaction ID, and we also need to order this by transaction ID in ascending order. So order by T dot transaction ID in ascending order. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. Not a very difficult question. All we had to do was from this table called transactions, what we did was we partitioned by the day, but before doing that partition, we formatted that day so that we only have the year, month, and date part, and then ordered by amount in decreasing manner so that the highest transaction on a particular day is ranked 1. Then since we are only interested in the maximum amount of the transaction, we kept where rank is equal to 1, and then what we did was we returned the transaction IDs and ordered by transaction ID in ascending order. So this is the 43rd video of the series called Project Employees Part 3, and if I look at the companies this question has been asked in, so Facebook, let's look at what the question has to say. We are given a table called project with two different columns, project ID and employee ID. The combined column is the primary key of this table. Employee ID is a foreign key that is a reference column to the employee table. Each row of this table indicates that the employee with employee ID is working on the project with project ID. We are also given a second table called employee with three different columns, employee ID, name, and experience years. Employee ID is the primary key that is column with unique values of this table. Each row of this table contains information about one employee. We are asked to write a solution to report the most experienced employees in each project. In case of a tie, report all employees with the maximum number of experience years. Order of the result does not matter. Okay, let's go through this example and see what do we need in our output. So here we have various different records in the project table as well as the employee table. And if we look at it, right, so for project ID 1, there are three different employees that work. Employee ID 1, 2, and 3. 1, 2, and 3 have experience of 3, 2, and 3 respectively. So the highest experience for project ID 1 is 3 years, which is of two people, Khalid and John. So for project ID 1, 1 and 3 should be in our output. Similarly, we can go ahead and do for 2. So if we look at our output, so project ID 1, there are 2 people who have the maximum experience, 1 and 3. So before solving this question, let's learn a simple thing about common table expressions. So what happens is that oftentimes our data requires multi-step transformation. What I mean by that is the data is not present in the way that we want in our final output. So we would have to do a lot of transformation. For example, we just saw in previous videos, we were ranking based on partitions, finding maximum, minimum, and so on. So you do a lot of transformations. Now, subqueries is one of the methods. Subqueries can be correlated subqueries, nested subqueries, which are good. But the problem with those subqueries is that it is very high processing time. If you followed about the video that I had on how a correlated subquery works, you will see that if there are 10 different rows in the table, the correlated subquery will run 10 different times, which is obviously a huge loss of processing power. So common table expressions come in handy in that because it only executes once, it improves the query performance and even reduces complexity, and you can treat it just like a table. So okay, so it will be more clear with the example. So the first thing, since in our output we need the project ID and employee ID, but the employee ID should be based on the highest number of experience. So obviously, since these two are in two different tables, the first thing that we need to do is join these. So from this table called project aliased as P, let me left join the employee table aliased as E on P dot employee ID is equal to E dot employee ID, and from the project table, what all columns do I require? Project ID and employee ID. So P dot star. And from the employee table, I only care about the experience years. E dot experience years. Let me go ahead and run this. Let's see what do we get in our output. So let me just drag it above. So this is what we have in our output. So for every project ID and the employee ID, what is the experience of that particular employee? Now, what I need is for every project ID, what is the maximum experience associated with the employees? So what I can do is I can partition by the project ID and calculate the maximum of the experience years. So what I can do is comma maximum of the experience years, and experience years is coming from employee table. So E dot experience years over, since this is a window function, so over partition by the project ID. So P dot project ID, and then let's alias this as max experience. Now let me go ahead and run this. Let's see what do we get in our output. So if I now look at my output, so this is what we have. So every project ID, the employees that are working, what are their experience and what is the maximum experience of that particular project. Now once I have this, then what I can do is I can store this in a common table expression. So with common table, and you can provide any name, I just go ahead with CTE. So as, and then this entire thing goes into parentheses. So basically what it does is this entire table that we have here right now, right, it is now stored in something called CTE, and then we can use it just like a table. From this, what all rows we require? Only where experience years is equal to the maximum, because that is what we all care about. So what we can do is simply go ahead from this common table expression, keep only those rows where experience years is equal to maximum experience, and in our output we only need the project ID and the employee ID, right? So, and since we do not need to order this by anything, these are the two columns that we require. Let me go ahead and run this now. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit to pass all the test cases. Yeah, this is accepted, and this is how we do it. So Somewhat tricky question, but if we know about common table expressions and what it looks like, how to write or make a common table expression, what we basically did was we joined the project table with the employee table so that we get the experience years. Then for every project ID, we found out the maximum experience and saved the entire thing in a common table expression. And then from that common table expression, we only kept those rows where experience is equal to the maximum experience. And for those rows, we just returned the project ID and employee ID. So this is the 44th video of this series called Find the Start and End Number of Continuous Ranges. And if I look at the companies this question has been asked in, so Microsoft, let's look at what the question has to say. We are given a table called logs with one column, log ID, the data type being integer. Log ID is the column of unique values for this table. Each row of this table contains the ID in a log table. We are asked to write a solution to find the start and end number of continuous ranges in the logs table. Return the result table ordered by start ID. Okay, let's go through this example. So here we have various records in the log ID column, and here what all consecutive numbers that we have 1, 2 and 3. So for this range, the start ID should be 1, end ID should be 3. Now again, there is another continuous range 7 and 8. So start ID 7, end ID 8, and 10 being alone. So start ID and end ID being 10. So that is what we have in our output. So one of the logic to solve this question could be somehow if we can assign the continuous ranges to a certain partition. So for example, 1, 2, 3 becomes one partition, 7, 8 becomes another partition, 10 becomes another partition. If we are able to assign continuous ranges into one particular basket, then our task would be easier. And one of the methods that we can employ is ranking. Okay, let me switch to Excel and try to demonstrate this concept. So here we are just taking some random numbers. So 2, 5, 7, then 9, 10, 11, 12. Obviously these yellow highlighted are the ones that are consecutive, and then there is another number 15. Now if we rank them in ascending order, so that the lowest is assigned rank 1 and then the next highest is assigned rank 2 and so on. So now once you have the ranks, and if you subtract the number and rank, you are going to get certain numbers. Now what is happening is that if your number increases by 1, that means it is consecutive, rank is always going to increase by 1, right? So rank is increasing by 1 irrespective of whether the number is consecutive or not. So if there is an increase, that is 9 to 1, that is plus 1, 4 to 5 again plus 1, the difference between the numbers is going to be exactly the same until and unless the continuity breaks. So from 9 to 12, the difference between number and rank is 5. So if we apply the same logic in our question, then we are able to assign, okay, these 1, 2, 3 can be one partition, 7, 8 can be another partition, and 10 can be another. Let's go ahead and try to rank this. So what I'm saying is, from this table called logs, let's keep the log ID column and then use the row number to basically rank. So row number, and then since this is a window function, over order by log ID in ascending order, and let's alias this as rank. Okay, let me go ahead and run this. Let's see what do we get in our output. So if we look at it, so this is what we have in our output. So these numbers, these IDs are assigned ranks. Now we just saw that if we subtract log ID and rank, we are going to get certain values. So if I go ahead and do log ID minus this row number, and let me alias this as, let me just bring it down here, as let's say I call this difference. Okay, let me go ahead and run this now. Let's see what do we get in our output. So now if we look at it, so this was ranked 1, the difference is 1 minus 1 0. This was ranked 2, so difference is 2 minus 2 0, and so on. So basically if you look at it, right, so same number is assigned to all the consecutive numbers, and then when the continuity breaks and then another continuous range is present, another different set of numbers are assigned. So now once we have this, what we can do is we can save this in a common table expression. So with CTE as, and then this entire thing goes into parentheses. So this becomes our common table expression, and we learned about common table expressions in our last video. And then what we can do is from this common table expression, we can group by the difference column. So group by the difference column and return. Okay, so return the difference column, and then the minimum becomes the start ID. So minimum of log ID is
your start ID. If you look at our output, it should be start ID. Then the maximum of log ID is your end ID, and this should be ordered by start ID in ascending order. So if let me just drag it down and order by start ID. Okay, let me go ahead and run this. Let's see what do we get. Still not complete yet. Yes, this says wrong answer because there is one column that is extra in our solution right now. But if you look at it, we have the start ID and end ID of all the continuous ranges. So 1 and 3, and then 7, 8, 10, and 10. So obviously in our output, all we need to do is remove this column because this was just for demonstration purposes. So if I just remove this part here, let me go ahead and run this now. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how to do it. So yes, very tricky question, and you have to use some of the logic. Then how can you find continuous ranges? And one of the intuition we just derived was if we assign ranks to consecutive numbers and subtract the difference is always going to be the same, and we can use that to basically create partitions. Here what I did was, once we have the similar numbers, right? So if I run to here, once we have this column, so you can just group by and find, okay, what is the minimum and what is the maximum. That becomes your start and end.
So this is the 45th video of the series called the most frequently ordered products for each customer, and let's look at what the question has to say. We are given a table called customers with two different columns, customer ID and name. Customer ID is the column with unique values for this table. This table contains information about the customers. We are also given a second table called orders with four different columns, order ID, order date, customer ID and product ID. Order ID is the column with unique values for this table. This table contains information about orders made by the customer ID. No customer will order the same product more than once in a single day. Then we are also given a third table called products with three different columns, product ID, product name and price. Product ID is the column with unique values for this table. This table contains information about the products. We are asked to write a solution to find the most frequently ordered product or products for each customer. The result table should have the product ID, product name for each customer ID who ordered at least one order. Okay, let's go through this example. Here we have various records in the customers table, in the orders table, in the products table, and in our output we need the product ID, product name and customer ID. So we do not need customer name, and customer ID is already in the orders table. So actually to solve this question, you don't even need the customers table, right? So we can use the orders table as well as the products table, and we need to find, okay, for every customer ID, what is the most frequently ordered product. So if we look at customer ID 1, so customer ID 1 orders product ID 1, 2, 2 and 2. So 2 is obviously ordered by this customer 3 number of times, which is the most. So in our output, we should have customer ID 1, product ID 2, and the name of the product is mouse. And that is what we have in our output. Similarly, we can go ahead and do for customer ID 2, 3, 4, etc. So to solve this question, since we need the name of the product as well as the customer ID and product ID, which are in two different tables, namely orders and products, the first thing that we should do is we should join these two tables. So let me switch to Excel so that I can demonstrate it. So this is what we have, orders table and the products table, and we can use the product ID column of the orders table and the product ID column of the products table to get the product name. So once we join, we are going to basically have this table. So 4 columns coming from the orders table and the product name coming from the products table, and this is what we are interested about. So let us go ahead and try to do this. So from this table called orders, aliased as O, if I left join the products table aliased as P on O dot product ID is equal to P dot product ID, and then we are only interested in what all columns. So select O dot star all 4 columns from the orders, even though we do not need this order date, but let's just keep it from for the sake. And then we are only interested in the product name. So P dot product name. Okay, so once we have this, then what we do is, now what we need to do is, for every customer ID, we need to find which product is the most frequently ordered product. So what we can do is we can make partitions. So for every customer ID, then for every product ID, what is the number of times it was ordered. So what we mean by that is we are going to have something like this. So customer ID 1
ordered two different products, product ID 1 and product ID 2, right? How many times product ID 2 was ordered? 3. And how many times product ID 1 was ordered? 1. Similarly, for customer ID 2, 3 different products order everything once. So how can we attain this? We can use the window function. So what we are doing is, let's count the order ID. So O dot order ID, so number of times a product has been ordered, by over partition by for every customer. So O dot customer ID and also O dot product ID. So for every customer, every product, how many times it was ordered. And let me alias this as frequency. So as frequency, let me go ahead and run this. Let's see what do we get in our output. So if we look at our output, right, so this is exactly the same thing that we have here, right? So this entire thing that, okay, for this particular customer ID, the different number of products, what is the number of times they have been ordered. So now once we have this, what we can do is we can save this entire thing in a common table expression called CTE1. So how can we do that? Let me just drag it down. CTE1 as, and then this entire thing goes into parentheses. And now what we need to do is, on this CTE1, what we can do is we need to find for every customer ID what is the highest ordered product. So what we can do is, from this common table expression 1, partition by the customer ID, order by frequency in decreasing manner, and assign ranks. So what we can do is, from this common table expression 1, if I do return all the columns, and let's make a new column by ranking. So dense rank, and then over partition by customer ID, partition by customer ID, and then order by frequency in decreasing manner, and let's alias this as rank. Okay, now let me go ahead and run this. Let's see what do we get in our output. So if I go ahead and see my output, it would be exactly the same. So here it is like difficult to visualize. Let me just drag it to the left if it would be easier. So yeah, this is exactly the same thing, right? So for example, customer ID 1 ordered 222 thrice. So this is ranked 1, and then this is ranked 2, and so on. So basically this is what, this is the table that we have here. Okay, we can write chained common table expressions. So we learned about common table expressions in our previous video in this series, that okay, common table expressions can be used to organize our queries. So we got the common table expression 1, and we can use this as a table. So in common table expression 2, right, we are basically using this CT1 and then adding a new column called rank. So how can we do this here? So let me just drag it down. So to write chained common table expression, you can just simply go ahead and put a comma and then write, okay, this is my common table expression 2, and this entire thing goes into parentheses. Okay, so CTE2 as, so now CTE2 basically is this table, and we are only interested in what all, rank is equal to 1, that is the most frequently ordered. So what we can do now is, from this common table expression 2, we are only interested in those rows where rank is equal to 1, and then we can return the customer ID, product ID, and product name. Okay, let me go ahead and run this. Let's see what do we get in our output. So if I look at my output here, I can see a number of repetitions, right? So to have only distinct pairs, I can just simply go ahead and write return distinct combinations of customer ID, product ID, and product name. So now this is accepted. My output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how we do it. So in this, what we learned is how can we write change common table expression. So here we perform the first common table expression by basically performing a join. Then we kept only the desired columns, as well as created the frequency column for every customer ID and product ID. Save this in a common table expression 1. So we used that to create another common table expression, and then based on that, we kept only those rows where rank is equal to 1, which basically signifies the most frequently ordered product. And then we kept the distinct combinations of customer ID, product ID, and product.
So this is the 46th video of the series called biggest window between visits, and let's look look at what the question has to say, we are given a table called users visit with two different columns, user ID and visit date. This table does not have a primary key. It might contain duplicate rows. This table contains logs of the dates that users visited a certain retailer. Assume today's date is 1st of January 2021. We are asked to write a solution that will, for each user ID, find out the largest window of days between each visit and the one right after it, or today if you are considering the last visit. Okay. Return the result table ordered by user ID. Let's go to this example and see what do we need in our output. So here we have for various different user IDs, the different visit dates. So if we look at, right, so for user ID 1, the first visit was on 20th of October 2020. Then the next visit was 28th of November 2020. So about 38, 39 days. Then after 28th of November, the next visit was on 3rd of December. So which is about what, 4-5 days. And then from 3rd of December, we are assuming that today's date is 1st of January 2021. So about 27, 28 days. So obviously the largest window is between 20th October and 28th November, that is about 38 or 39 days. So if we look at in our output for user ID 1, the biggest window is 39. Similarly, we can do that for user ID 2 and 3. Okay, so to solve this question, what we can do is, we can partition by the user ID, arrange the visit date in ascending order, and try to get, okay, use the lead window function to get what is the next visit date. So let's start doing that. So from this table called user visits, if we keep both the columns, so return star, and then let's use the lead window function and get the next visit date. So visit date, and we need the next one, right? So that is why we write 1, and since this is a window function, we write over, and we need this for every user ID. So partition by the user ID and order this by visit date, right? So because we need to start from the first visit, then the second visit, and so on. So visit date, and let's alias this as next, right? So our next visit, whatever suits you. So let me go ahead and run this. Let's see what do we get in our output. Let me just drag it above. So here, if we look at our output, so the first one was on 28th of October, then 28th of November, then 28th of November and 3rd of December, and from 3rd of December to null. Okay, now this is null. So these nulls should be imputed with the current, because the today we need to assume that today's date is 1st of January 2021. These nulls should be imputed using this value, because then only you can calculate the number of days between 3rd of December till 1st of January 2021. Similarly, 9th of December, 1st of January 2021, and so on. So we can provide the third parameter in the lead, that okay, once you get the lead and wherever it comes out to be null, you can impute it with something. So what we can do is we can write here, so if it is null, then 2021 0101. Okay, let me just bring it down here so that it's easier for us to read. Okay, let me go ahead and run this now. Let's see what do we get in our output. So now if we look at it, so those nulls are imputed by 1st of January 2021. Now what we can do is we can save this entire thing in a common table expression. So with CTE as, and then this entire thing goes into parentheses. So this becomes our common table expression. And then from this common table expression, what we can do is we can get the difference in next and visit date, so that we get the number of days between them. So return all the columns, and then we use the date diff, which actually calculates the number of days between two dates. So next and visit date, and let me alias this as, let's say, difference. Let me go ahead and run this. Let's see what do we get in our output. So if we look at it, right, so the difference between these two is 39, 5 days, 29 days, and so on. So now once we have this, then what we can do is we can group by the user ID and find the maximum difference, and that is going to be the biggest window that we need. So either you can save this in another common table expression and go ahead and do that, or basically you can go ahead and do this. So if you are calculating this difference column, right? So obviously you have user ID, visit date, and next. You can group by the user ID and then get the maximum of date diff of this. So what I'm saying is, from this, group by the user ID, and then what you do is return the user ID and then get the maximum of date difference between next date and
visit date and alias this as, right? So this entire thing becomes maximum of this and alias this as whatever is required in our output. So as biggest window, so biggest window, and we need to also order this by user ID, right? So order by user ID. So we can go ahead and write order by user ID. Okay, so let me just drag it down. So this is how it looks. I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted and this is how we do it. So somewhat tricky question, but what we had to do was we just used the window function lead to get the next visit date so that we can use the current visit date and the next visit date to get the difference between the two dates, so that we can then group by the user ID and calculate the maximum difference. And that is what we have as the biggest window. So this is the 47th video of this series called All People Report to the Given Manager. And if you look at the companies this question has been asked in, so Adobe and Google, let's look at what the question has to say. We are given a table called employees with three different columns: employee ID, employee name, and manager ID. Employee ID is the column of unique values for this table. Each row of this table indicates that the employee with employee ID, and the name, employee name, reports his work to his or her direct manager with manager ID. The head of the company is the employee with employee ID equal to 1. We are asked to write a solution to find employee ID of all employees that directly or indirectly report their work to the head of the company. The indirect relation between managers will not exceed 3 managers as the company is small. Order of the result does not matter. Okay, let's go through this example. So here we have various records of employees, their employee ID, name, and manager ID in the employees table. So let's look at what all employees directly or indirectly report to the boss. If we look at it, right, so employee ID 3 is a manager of itself and does not report to boss. So 3 should not be in the output. 2 reports directly to 1, so 2 should be in the output. 4 reports to 2 and 2 reports to 1, so indirectly 4 reports to 1, so 4 should also be in the output. 7 reports to 4, 4 reports to 2, 2 reports to 1, so 7 should also be in the output. 8 reports to 3, but 3 does not report to 1, so 8 should not be in the output. Similarly for 9 and 77 directly reports to 1. So 2, 4, 7 and 77 are the ones that we need in our output. Now, since the question mentioned that the indirect relation between managers will not exceed 3 managers, you can take two routes to solve this question. The first is using self joins, which we are not going to do, but just want to mention it here. So what you can do is you can join the table on itself twice so that you can get maximum third level of manager, and then you keep certain rows. But let's learn about how to do this using recursive common table expression, because if this statement was not mentioned, so you do not know that up to what depth level this can go. So it would be better to learn about recursive common table expression. So we learned about normal common table expressions until now, but let's look at how a recursive common table expression is written. So to write a recursive common table expression, you need to add the word recursive after the with clause. So a normal common table expression is with common table expression as, and then whatever you write in parentheses, and then you simply do select star from common table expression, right? So this is the normal syntax. But if you want to write a recursive common table expression, you need to add, okay, recursive common table expression as, and then whatever you need. Now in this, what you need to have is, firstly you need to have an anchor member, right? So there is something called anchor member, and then using union or union all, right? You can have one of the two depending upon the type of question and whatever you required in our output. Union all, you need to union this with something that we call recursive member. Okay, so now following this, let's try to solve this question. So I've just copied this in Excel so that everything is at one place, so that I can demonstrate you visually how this entire thing is actually working. So this is the table that we have: employees, employee ID, employee name, and manager ID. This is the query that I have written. So this is the anchor member, that from this table called employees, keep only those rows where manager ID equal to 1, basically the person is the boss, and employee ID is not equal to 1, so that we ignore rows like this. Okay, so this becomes your anchor. then this is the recursive part, that hey, from this employees table aliased as E, inner join the common table expression aliased as C on E dot manager ID. So manager ID is equal to employee ID column that we get from the common table expression. So now these are the two members that we have, anchor member as well as recursive member. Now let's look at how this is actually solving this question. Let me just copy and paste this entire thing back into my SQL query. Okay, so this is how this looks. Now let's try to see how this is actually working. So we have written with recursive common table expression as, so this entire thing, right? So let me just read, this entire thing actually will give you two rows, right? So the first pass is, this is going to give you employee ID 2 and 77 because that is the only time. So here manager ID is equal to 1 and employee ID is not equal to 1. Similarly in this one, so you are returned with 2 and 77. Now what is the recursive member? In the recursive member, what do we have? We have from this employee tables join a inner join. So basically the rows should be present in both of them. Common table expression CTE. Now right now CTE has nothing, right? Because this is just the first pass. So this entire thing is going to produce you how many rows? 0 rows. So you have nothing here, and then you union it, right? So here you have the union function. So here you have 2 rows, here you return 0 rows. So 2 rows plus union 0 rows, you are returned with 2 different rows. So yeah, 2 new rows are added to the common table expression. Remember, we just said that CT currently had 0 rows. Now after pass 1, they has 2 new rows. Okay, so now this is what common table expression CTE stores. Then in the second pass, what happens is it again goes, okay, return employee ID from employees where manager ID equal to 1 and employee ID not equal to 1. So again, this will produce the same 2 rows. Now, since the common table expression has these 2 new rows, 2 and 77, it will try to find, okay, we are performing an inner join of the employees table. So employees table, basically it will try to say if you have 2 or 77 in the manager ID. So you do not have 77, but you do have 2. So with 2, it will find a match and it will return E dot employee ID, that is employee ID. So it will return 4, right? So here recursive member is going to return you 4. So now this is you have from the anchor member, this is what you have from the recursive member, you union them, so you get 2, 77 and 4. So this is another new row that has been added. Now again, this entire thing becomes your common table expression CTE. Now pass 3, again the anchor member is producing the same thing, but now since you have 277 and 4, so 2 already we saw that it produces 4. 77, there it won't produce anything because there is no 77 in the manager ID, but 4 will produce another row called 7. So here you have 4 and 7, and when you union these two members, you get 277, 4 and 7. So here again you are ending up with a new row. So at the end of pass 3, common table expression has 277, 4 and 7 stored in it. Now again pass 4, anchor member produces the same thing, but if you look at it, right, so 277, 4 and 7. So 2 produces 4, 4 produces 7, 77 does not produce anything because here you have an inner join. Remember, it is an inner join. 77 did not produce anything. Similarly, 7 also do not produce anything because manager ID is not 7. What are the 2 rows that it will produce? 4 from manager ID 2 and 7 from manager ID 4. So it will produce the same thing that it produced in pass 3. So no new row is added. So when a no new row is added to the existing common table expression, the common table expression terminates. So at the end of pass 4, CTE will store this 277, 4 and 7. These are all the employee IDs who are actually reporting directly or indirectly to the boss. So if I go back here, right now after all the passes, it will have only one column, right? This common table expression will have only one column called employee ID. So if I return everything from it, if I go ahead and run this, let's see what do we get. So yeah, if we look at it, this is accepted, our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how to do it. So yes, tricky question, plus we had to use the recursive common table expressions in this. What we basically learned about recursive common table expression is that you need to have two members joined by a union or a union all. The first member is called an anchor member, and then second member is a recursive member, which actually keeps on adding one or more rows to your common table expression, and the moment it will not add any new row, it will stop executing. It is something just like a while loop that we study, and then once it terminates, you can return whatever you require from your common table expression.
So this is the 40th video of this series called Find the Quiet Students in All Exams, and the difficulty level of this question is hard. Let's look at what the question has to say. We are given a table called student with two different columns, student ID and student name. Student ID is the primary key, that is column with unique values for this table. Student name is the name of the student. We are also given a second table called exam with three different columns, exam ID, student ID, score. The combined columns exam ID and student ID is the primary key, that is combination of columns with unique values for this table. Each row of this table indicates that the student with student ID has a score points in the exam with exam ID. A quiet student is one who took at least one exam and did not score the highest or the lowest. We are asked to write a solution to report the students, that is student ID and name, being quiet in all exams. Do not return the student who has never taken any exam. Return the result table ordered by student ID. Okay, let's go through the examples and try to understand what this question is asking us. So here we have multiple records in the students table as well as the exam table. So if we look at, so out of these five different students, student ID 1, 2, 3, 4 and 5, which student has at least taken one exam and has never scored a highest or a lowest in any of the exam? So if we look at student ID 1, so student ID 1 in exam ID 10 has scored the minimum marks, and student ID 2 has medium, and then student ID 3 highest marks. So just by looking at one exam, we can eliminate that, okay, student ID 1 and 3 can be eliminated from here. Again, for exam ID 2, for student ID 1, it is maximum as well as minimum. For exam ID 30, 1 has the minimum, 4 has the highest, and 3 is already eliminated. Why? Because 3 has scored the maximum marks in exam ID 10. So until now, 1, 3 and 4 has been eliminated. For exam ID 40, 1 has scored the minimum, so already eliminated. 4 maximum already eliminated. So 2. 2 is someone who has at least taken one examination, and in none of the exams the person has scored highest or the lowest mark. Student ID 5, Will, has never taken any exam. So the only person that could be in our output is student ID 2, which is Jade, and that is what we have in our output. So to solve this question, what we can do is we can try to find out that, okay, for every exam ID, what is the maximum score and minimum score, and then we can save this in a common table expression, and then based on that try to find out which all students have at least one scored minimum or maximum, and then using that table we can try to filter the student table. But let's go step by step. So the first thing that we should do is let's add two different columns, maximum and minimum scores for every exam ID. How can we do that? From this table called, right, so from this table called exam, what we are doing is let's keep all the three columns and try to make another column. So let's firstly get the maximum value of scores in each exam ID. So maximum of score over partition by, so partition by the exam ID, right? And let's alias this as maximum score, and then similarly get the minimum score. So minimum of score over partition by the exam ID, and let's alias this as minimum score. Okay, let me go ahead and run this. Let's see what do we get in our output. So here, if we look at our output, so this is what we have. So for every exam ID, what is the maximum score? So maximum score for exam ID 10 is 90 and minimum score is 70. So once we have this, then what we can do is let's save this in a common table expression. Let's call that common table expression with min max s, and then this entire thing goes into parentheses, right? So this entire thing goes into parentheses, and then what we can do is from this min max, now here once you have the maximum score and the minimum score, then what you can do is from this min max common table expression, wherever your score is equal to the minimum value or your score is the equal to maximum value, then
for them we can find out the different student IDs, because in our output we do not need such students who have scored minimum or maximum scores even once. So we need to find out that student IDs, right? So what we can do is, from this table or from this common table expression min max, we are going to keep those rows where either your score is equal to the maximum value or your score is equal to the minimum value. So in those cases, return the student IDs. Or let me just right now for do select star, let's keep who all students are and what their scores are. So if you look at our output, so this is what we have. So let me just drag it above. So here we have student ID 1, 3, and 4, just as we described, right, while we were discussing this question, that yes, student ID 1, 3, and 4 at least once have scored either the minimum part, right? So here student ID 1 has scored minimum. In some cases, they have scored maximum as well. So these are the three students 1, 3, and 4 that have scored minimum or maximum at least once, and they should not be included in our output, right? Because those are not a quiet student according to the definition of the question. Okay, so from here we can get that, right? So what we can do is, let's save this also into another common table expression as students who scored min max. So how can we write changed common table expression? I have explained this in my previous video. So here you can simply go ahead and write the new name of the second common table expression. So let's say scored min max, and let's alias this as, and then this entire thing goes into parentheses, right? And then what we can do is, so we are only required to keep the student ID. Distinct student ID is going to be the list of all the students who have either scored minimum or maximum value. Then what we can do is, now using these things that we just created, what we can do is we can filter the student table. So from the student table, we are only going to keep those students where student ID is in, right? So student ID is in. Firstly, the student should have taken the exam at least once. So if the student has taken the exam at least once, the student ID should be appearing in the exam table. So return distinct student ID from the exam table. So that is going to eliminate rows like or students like Will who have never taken an exam. And we also need to make sure the student is a quiet student. So and student ID is not in the list of students who have at least scored minimum or maximum value once. So return student ID from the scored minimum or maximum student list, right? For them, what we can do is we can go ahead and return both the columns, because we need both of them in the output, and they should also be ordered by student ID. So if I go ahead and do order by student ID. Okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit this to pass all the test cases. So yeah, this is accepted, and this is how we do it. So somewhat tricky question, plus it is a hard difficulty question as well. But what we did was, firstly, we used the exam table to create the minimum and maximum values of every exam ID, so that we can try to find out who all students have scored at least minimum or maximum in any of the exam even once. We got the list of those students, and then what we did was we used the student table and filtered only those rows where either the student ID appeared in the exam table, so they have taken the examination, and they have never scored minimum or maximum. So we made sure both of those conditions are true using the where clause, and then we return both the student ID and student name ordered by the student ID. So this is the 49th video of the series called Find the subtask that did not execute. The difficulty level of this question is hard, and if I look at the companies this question has been asked in, so Google, very important question. Let's look at what the question has to say. We are given a table called task with two different columns, task ID and subtask count. Task ID is the column with unique values for this table. Each row in this table indicates the task ID was divided into subtask count subtask labeled from 1 to subtask count.
It is guaranteed that subtask count is between 2 and 20 included. There is also a second table called executed with two columns, task ID and subtask ID. The combined column task ID and subtask ID is the combination of columns with unique values for this table. Each row in this table indicates that for the task ID, the subtask with ID subtask ID was executed successfully. It is guaranteed that subtask ID is less than equal to the subtask count for each task ID. Okay, we are asked to write a solution to report the IDs of the missing subtasks for each task ID. Order of the result does not matter. So it like sounds very confusing, but it is not that confusing. Let's go through this example and see what the question actually means. So here we have various records of various three different tasks and the number of subtasks in each of them. And then there is the executed table where we basically have for every task ID which subtask executed successfully. So here, if you look at it, so task ID 1 has three different subtasks 1, 2, and 3. 2 has been executed successfully. So, for task ID 1, subtask 1 and subtask 3 has not been executed. For 2, there are two subtasks 1 and 2. Both of them have not been executed successfully. And similarly for 3. So, in the output we are going to have, so for task ID 1 there are two subtasks that were not executed, for 2 there are both the subtasks were not executed, and for 3 all the subtasks were executed successfully, 4 subtasks and 4 of them executed successfully. So what makes this question hard is the way the data is present in the task table. We need to make sure this task table is actually converted into form that we want. So our first task should be to actually convert the data that we have in the task table in form of the total number of subtasks to be broken down by the subtask ID. So instead of having one row for task ID 1 and total number of subtasks, we should have three rows. Task ID 1, subtask ID 1, task ID 1, subtask ID 2, task ID 1, subtask ID 3. How can we do that? So we learned about recursive common table expression just a couple of videos back, where we learned that to write a recursive common table expression, we first need to write, okay, so with recursive and then name of the common table expression, then as, and then everything goes into parentheses. Now in parentheses, you need to have an anchor member, union that with a thing that we have called recursive member, right? Okay, so now how do we get the anchor member and recursive member? Let me switch to Excel so that I can demonstrate it visually. So here we have the task table and we have the executed table. Now our first task is to convert the task table into a form that we want. So ideally what we want is, we want task ID 1, subtask ID 1, task ID 1, subtask ID 2, task ID 1, subtask ID 3, and similarly for other tasks. So the anchor member becomes return task ID and subtask count from the task table, and then what you do is from the common table expression where your subtask count is greater than 1, take the task ID but subtract 1 from the subtask count. Okay, let me go ahead and copy paste this here back in the SQL query, and then we can discuss what it actually means. So this is the code that we have. Let's look at how it is being executed exactly. So for the first pass, right now what do you have in the common table expression? Here you have nothing, right? So in pass 1 it will say, okay, from the anchor member take both the columns from the task table, task ID and subtask ID. This is what is returned from the anchor member. And since there is nothing in the common table expression in first pass, so when you union these two things from anchor member and recursive member, this is what you have stored in the common table expression. So task ID and subtask count. Okay, now once you have this is what is stored in common table expression. Then in second pass, what happens is, again it will try to find out, okay, return task ID and subtask count from the task. So it returns the same thing in pass 2 from the anchor member. But now since the common table expression had this thing is stored, so here what you need is from that common table expression. So common table expression right now is this, where subtask count is greater than 1. So in all the three rows subtask count is greater than 1. What you do is take the task ID and decrease 1 from the subtask count. So here what we will have in the recursive member, 1, 3 minus 1 is 2, 2, 1, 3, 3, and that is what you have here. So when you union these two things, this is what you get. So these are the three rows that you had initially, and three new rows have been added. We know that if at least one new row is being added in the recursive common table expression, then the recursion keeps on working. Now this is what is stored in common table expression after pass 2. Now again, pass 3, anchor member returns the same thing. Now here what we need is from this common table expression where your subtask count is greater than 1. Subtask count is greater than 1 in all the rows except this row. So this row will be excluded, and then 1 is subtracted from this and everyone else. So what you are going to have: 1, 2, 2, 1, 3, 3, 1, 1. This is already excluded. Why? Because here you already have, right, where subtask is greater than 1, and then 3, 2. So this is what you get from the recursive member after pass 3, and when you union these two things, here you get the desired common table expression. Again, two new rows have been added. Similarly, for pass 4 and a new row is added, this is what you have at the end of pass 4. Now if you look at it, pass 5 returns the same thing in anchor member, and here again greater than 1. So row number this and this is excluded. And now if you look at it, so 1, 2, 2, 1, 3, 3, 1, 1, 3, 2, 3, 1 is exactly the same as what you have in past 4. So obviously when you perform the union, you are going to end up with the same things that you ended at the end of past 4. Since there is no new row added, the recursion will stop, and this is what you have in the common table expression in the final pass. So now just look at it. Here you had task id 1 and the number of tasks were 3. So here in the output you have 1, 3, 1, 2, 1, 1, right? Similarly for task id 2, you have two different tasks. So you should have 2, 2 and 2, 1. So you have 2, 2 and 2, 1. And similarly for 3. So now your data is in the manner that you wanted in the first place. Now what you can do is from this common table expression, right? So after running, what happens is then from this common table expression, we are only going to keep those combinations of task ID, right? So task ID and subtask count. So subtask count, which is not in the, if you return the executed table. So these are the ones that are executed, and obviously the combinations of task ID and subtask ID that is not in the executed table are the ones that are not executed, and which is what we want in our output. So return both the columns from executed, and what we need is return the task ID and alias the subtasks. What we need, what do we have as subtask ID, right? So subtask ID. And since we do not need to order this by anything, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. Yeah, this is accepted, and this is how we do it. So yes, very tricky question, hard, as well as you need to know how recursive common table expression works. What we basically did was we had an anchor member, and then we used the common table expression recursion to actually, convert the data that we have. So basically break down by the number of rows for every subtask that occurs in a particular task ID. And once we have the data in the required format, then it was just a matter of performing a filter that whenever your task ID and subtask count is not in the list of executed subtasks, then obviously those tasks are missing, and that is what we get in our output. So this is the 50th video of the series called report continuous dates, and the difficulty level of this question is hard. And if I look at the companies this question has been asked in, so Facebook, very important question. Let's look at what the question has to say. We are given a table called failed with one column, failed date. Failed date is the primary key, that is column with unique values for this table. This table contains the days of failed task. Then we are also given a second table called succeed date with another one column called success date. Success date is the primary key for this table. This table contains the days of succeeded tasks. A system is running one task every day. Every task is independent of the previous task. The task can fail or succeed. We are asked to write a solution to report the period state for each continuous interval of days in the period from 1st of January 2019 to 31st of December 2019. Period state is failed if the task in the interval failed, or succeeded if task in this interval succeeded. Interval of the days are retrieved at start date and end date. Return the result table ordered by start date. Okay, so let's go through this example and see what we basically need in our output. So here we have various records in the failed table as well as succeeded table. So let's look at, so we need to start from 1st of January 2019. So 1st of January 2019, it was a success. Then on 2nd and 3rd, so all the 3 days it was a success, and then 4th of January was a fail. So the first should be period state is going to be succeeded, start date 1st of January 2019 and end date 3rd of January 2019. Then on 4th of January and 5th of January, the period state was failed. So 4th of January to 5th of January it was failed, and then on 6th of January it was succeeded. So that is what we have in our output. Now if you remember, the 44th video of this series was finding a very similar kind of stuff where we developed a logic. Let me go through the logic very quickly, that what we discussed. So here let's suppose we have some numbers, some of them are continuous and some of them are not. So for example, the number we have is 5, 6, 7 and then 11 and 12. Now if we rank them based on ascending order, so this will be assigned rank 1, 6 is going to be assigned rank 2 and so on. If we calculate the difference between the number and the rank, the continuous numbers are always going to return the same difference. So 5 minus 1 is going to be 4, 6 minus 2 is going to be 4 and so on. And the moment the difference changes, it means that there is a discontinuity, right? So now once we have this kind of stuff, then what you can do is you can simply group by the difference column, because it is basically 4 and 7, they are signifying that there are two different groups, and in this particular group what is the minimum number 5 and maximum number 7. Similarly in this particular group, what is the minimum number 11 and maximum number 12. Now we can use this logic to basically extend in our solution here as well. So the first thing that we should do is, since the failed task as well as the succeeded task are in two different table, why not we go ahead and combine this into one particular table and have another column which basically tells on a particular day did the task fail or succeed. So this is what we have, right? So failed table and then the succeeded table, and what I'm saying is let's combine these two in a column called date and have a state. So we know that on 28th of December 2018 it was failed, on 29th again. So we are going to create a column called state which basically tells on every date what was the status, failed or succeeded. So let me go ahead and start doing that from the table called failed. Right, so first thing we are going to do is perform a union. So from this table called fail, what I'm doing is I am return me the failed date as date and create a column and fill it with values called failed and alias this as state. And then what you do is you do the same thing but with the succeeded table and union them. So basically what you are going to do is union this with return success date, right? So success date as date and succeeded as state. So succeeded as state from the table called succeeded. Okay, let me go ahead and run this. Let's see what do we get in our output. So if I look at my output, this is what we have. This is the same thing exactly that I just showed you, right? So here we have all the stuff. Now what we can do is we can save this in a common table expression called CTE, right? So basically we union the dates. So let me go ahead and write with common table expression as, and then this entire thing goes into parentheses. Once this common table expression is created, then what we are doing is for every particular state, let's try to rank the dates in ascending order. So when we say failed, right? So the first rank is going to be assigned to 28th of December. Second failure is going to be on 29th of December. Third failure is on 4th of January, 5th of January, and so on, right? So we are going to assign ranks based on the state. So here you have rank 1, 2, then 3, 4. Similarly for succeeded 1, 2, 3, 4, 5, and 6. So how can we do that? Basically from
the common table expression, we are going to have return both the columns, and then let's create a row number, right? So let's rank them row number over partition by state, and then order by date, and then let me alias this as rank, and let me go ahead and run this. Okay, so if we look at it, so what do we have is rank 1 2 3 4, and then 38th of December, 31st, 1st, all this we have the ranks, right? Just like we saw. Okay, now what we are going to do is, once we have the dates and the ranks, then we are going to apply the same logic. Instead of having the numbers and the ranks, we have the dates and the ranks, and if we subtract the two, we are going to end up with the same difference. Here the difference was a number. In our case, it is going to be a particular day. So what I'm saying is, let's save this entire thing into a common table expression CTE2, right? So CTE2, and here we are writing chained common table expression. I have already discussed the syntax and how it works in detail in our previous videos. So CTE2, this entire thing goes into parentheses again, and then what we are doing is, from this common table expression 2, we are going to keep all the three columns, and then we need to subtract. So there is a function called date subtract. From the date column, I need to subtract what? Interval rank day. And let me alias this as group. Let me switch to Excel again. So basically what we are doing is subtract date minus these many dates, right? Because that is going to give you dates that can be used to basically group. These two are continuous dates. So if you subtract them, you are going to end up with the same date. Similarly, from 30th of December 2018 till 3rd of January 2019, everything succeeded. So if you subtract these two columns, you are going to end up with the same date, right? Okay, so similarly what we are doing is, we got the things, right? So if I go ahead and run this, let's see what do we get in our output. So if we look at our output, this is what we get. Exactly the same thing that we were discussing. Now, once we have this, then what we can do is, now the question says that, if I go back to the question says we are only interested in dates between 1st of January 2019 and 31st of December 2019. What I can do is, I can store this entire thing in another common table expression, right? So CTE3 aliased as, and then this entire thing goes into parentheses again. And now from this common table expression 3, I am only interested in those rows where the date column is between 1st of January 2019, right? And then and 2019 December 31st, right? So this is what we need to make sure of. So if I go ahead and look at this, so these are the only rows that we are concerned about. And then what I can do is, I can group by the group column as well as the state. Why we need the state? Because we need that in our output, right? So the whether it failed or succeeded, we need that on our output. So if you only group by the group column, you won't be able to return the state column, right? Because that is a property of group by that we learned very early in our series as well. So what we can do is, we can go ahead and write group by the group column, and we do not need anything regarding group, right? We just created this as a ticker to identify various continuous dates as separate groups. So group by this and group by the state as well, because we need the state in our output. Return the state column, and it should be aliased as period state. And now from each group, the minimum becomes the start date and maximum becomes the end date. So minimum of date is your start date, right? And maximum of date is your end date. And this should also be ordered by start date in ascending order. So order by start date in ascending order. Okay, let me go ahead and run this. This is accepted and our output is same as expected output. Let me go ahead and submit it. So pass all the test cases. So this is accepted and this is how we do it. So Very tricky question, but if you know how we can use the logic to find the continuous dates, we already learned about this in question number 44. What we basically did was, let me switch back to Excel. So we combined the two tables into one and have a column called state, which basically tells every particular day did the task fail or succeed. Once we had that, then by every state we ranked them, and then we use the logic that if the dates are continuous, if you subtract the date and the rank column, you are always going to end up with the same number if the dates are continuous. And once we have the identifier, we can use that to basically say that, okay, in this particular group, what is the minimum date and the maximum date. Since we were only concerned about dates that are in 2019, so 1st of January till 31st of December, we are only, going to look at these shaded rows, and then we found for every group what is the start date and end date. So yeah, this is how we do it. Let me know if there's a better way or more efficient way to solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.